last 20 to 30 years has migrated to China. And so China's emissions have risen rapidly. Ours haven't so much, but that's in part because we're not doing as many industrial things as we used to create CO2 emissions. So the question is then, how do we reduce the growth of our greenhouse gas emissions? So accepting the fact that it's not a good thing to continue making the atmospheric concentration of carbon dioxide and other greenhouse gases grow, how can we slow it down? Well, obviously we can produce fewer greenhouse gases in our daily lives, and suggested a few different things here. And a lot of these activities we've done, as I mentioned before, for example, in the United States, has greatly reduced their greenhouse gas emissions arising from electricity generation by replacing their coal-fired generation plants by gas-fired plants. The other thing we can do on top of producing fewer greenhouse gases is to actually capture the carbon dioxide that's emitted from the various things we do and either use it to make useful things, which is carbon utilization, or to store it securely underground, carbon storage, or also known as sequestration. And in fact, most serious sort of schemes or outlooks to reduce our greenhouse gas production over time includes an element of carbon capture and storage. So this report that was done by the International Energy Agency in 2021 and then updated a couple of years later, well, they put together kind of a bunch of ideas. The graph in the middle with the colors just schematically shows, well, in 2020, we're producing about 34 gigatons per year. That's billion tons again, carbon dioxide. And if we do all of these things that are listed in the upper part of the slide here, let me see if I can get my little, there we go, that's better. So if we do all of these different things, then that will help reduce the net CO2 emissions so that by 2050, we get down to a very low level. But you'll notice along the bottom here that they do include very significant amounts, 4 gigatons by 2035, annual 7.6 gigatons of carbon dioxide captured. So in other words, the plan to get down to net zero greenhouse gas emissions includes actually capturing a lot of carbon dioxide from various sources where it's very hard to prevent actually producing CO2. For example, making cement, other industrial processes, some very special aviation fuels, things like that. If we're going to significantly decrease our greenhouse gas emissions on a net basis, some of that saving has to come through actually capturing and storing the CO2. So what does that actually mean? A little schematic diagram here. If we take some sort of strong emitter of carbon dioxide, perhaps a coal-fired generating station, perhaps a cement plant, something like that, well, instead of just allowing the CO2 to come out the smokestack and go into the atmosphere, we can actually pass the flue gases or the combustion gases through a scrubber that will capture the CO2 before it hits the atmosphere. And once we've got that chemically captured, we can either utilize it, and there's a bunch of different things that people propose to do with captured CO2. And there's lots of interesting research going on, but I have to say to date that the amounts of CO2 that are actually being utilized that way are still very, very small. The big potential to get rid of or to prevent this CO2 from escaping to the atmosphere is to store it underground, either directly into saline aquifers that I'll talk about in a moment, or actually re-injecting it into, for example, existing oil pools, a process called enhanced oil recovery. We'll look at that. Either way, we're putting the CO2 underground and preventing it from ever getting into the atmosphere. So that's sort of the general scheme of things. So if we look at the opportunities, well, across North America, here's a little map of all of the major emitters of carbon dioxide. And so the blue dots, for example, are electrical generation stations. So you can see in the eastern United States, there's still a lot of coal and gas-fired power plants that emit a lot of carbon dioxide. We've got them in Alberta and Saskatchewan. Uh, None that show up on the map in British Columbia, obviously, because of the hydropower. Red is petroleum, so most petroleum activity, producing gas, producing oil, producing heavy oil. You can see in northeastern Alberta, there's a lot of emissions associated with oil sands production. Oil refineries in purple. Here's an interesting one, ethanol. So ethanol, we produce it as a biofuel from corn, mostly from corn, at least in North America. And so it's not surprising in the Midwestern United States, we've got all of these ethanol plants that are taking corn and converting them to the biofuel ethanol. Then there's also cement plants and industrial applications. A key thing about these large CO2 emitters is that the waste gases they produce are very high in CO2. They're from 15 to 100% CO2. And in fact, ethanol plants produce almost 100% CO2 as a byproduct. And so they're actually very, very good targets for carbon capture and storage because we're dealing with very high concentrations. Now, there's also a branch of carbon capture that called direct air capture, where people propose to actually just take CO2 out of the atmosphere and once it's captured, again, utilize it or store it in exactly the same fashion as you would the CO2 that's from a coal-fired plant or a cement plant or things like that. But the big, and this just a picture of the Carbon Engineering Innovation Center in Squamish, one of the world-leading facilities for understanding how best to do direct air capture. The problem is that with direct air capture, we're working with trying to take CO2 out of the atmosphere where the concentration is 420 parts per million or 0.042%. So in doing direct air capture, we're working with something that is orders of magnitude less concentrated than the waste streams from cement plants or generating stations or ethanol plants. And so takes a lot more energy. It's a lot harder and more expensive to actually capture CO2 from the atmosphere than it is to capture it from an industrial facility where the concentrations are much, much higher. However we do it, the operation for carbon capture and storage is, well, over on the left, whatever the facility is, again, a cement plant, an ethanol plant, we capture the CO2 from using chemical processes before it escapes up the smokestack, and we pass it through some processes here where it's purified. We take the water out of it, and then it's compressed so that we can easily transport it through pipelines, and we transport it to a CO2 storage site, which is basically a place where we've determined from a geological and engineering analysis that we can safely inject a lot of CO2 underground and that it's going to stay there. So this CO2 transportation can be over very long distances if we don't have any local opportunities, or it can be very nearby. And I'll show you some examples of that a bit later on, particularly existing CO2 transportation in Alberta. And just a couple of pictures. In Norway, they're one of the largest carbon capture, CO2 capture facilities in this big cement plant. And that's kind of what it looks like. And then over on the right, a picture of some injection wells in Western Australia where they're injecting CO2 from a project called Gorgon, which I believe is capturing CO2 from petroleum operations. So this little white guy right in the middle here is the actual wellhead where the CO2 is injected down into the ground. So looking a bit more closely at subsurface storage itself, this is just sort of a cartoon diagram sliced through the earth here. And so here we are at the surface with our CO2 extraction and things like that. We drill these wells from the surface down through shallow fresh water, down through various formations until we get down to deep under the earth, and usually 1,000 meters or more deep. We get to these formations that have high quality reservoirs. I'm going to talk about those in a moment, but basically we're looking to put the CO2 into porous and permeable reservoir rocks. Now, naturally, they're already full of fluid. In most cases, very saline waters, which are there naturally, or in some places, oil and gas. We're looking, we're putting carbon dioxide back into exactly the same reservoirs that we take oil and gas out of. An important feature of the whole system here, another one on top of the reservoir, is the containment. If we want the carbon dioxide to stay underground for millions of years so that it doesn't escape to the atmosphere, there has to be something above it that's impermeable. And so that's this black layer here schematically. And usually that's something like a shale or a rock that's compressed from mud and things like that. Very impermeable. The gas can't get through it. I'll talk a bit more about that too. Just a note about the carbon dioxide itself. When we actually inject it, it's injected in what's called the supercritical phase. So when CO2 is a gas, it occupies a lot of space, and it would quickly fill up any of that subsurface storage volume that we've got. But as we compress that and inject it underground where there's more pressure, the volume of carbon dioxide that might be, say, 100 units at the surface quickly becomes much less, say 1.1 units in the subsurface. Once we get it down below what's called the critical depth, or a temperature and pressure conditions where the CO2 naturally evolves from a gas into this supercritical phase, it becomes much less dense, so that 100 volumes of CO2 at the surface become only about a quarter of a volume, 1/400th as much in the deep subsurface. So we can put a lot of CO2 underground once it's compressed and in this supercritical phase. Yeah. Okay. So where do we do all this? Well, this is a little cartoon of the Earth's crust from the Rocky Mountains in the west and then eastward across the plains in Alberta. And I'm sorry for not showing a British Columbia example, but the fact of the matter is British Columbia is not blessed nearly as much with the right types of rocks and potential for carbon storage as Alberta and Saskatchewan are. So we can see these continuous layers in the different colors of sedimentary rocks. Some of them are reservoirs. Let's say the blue one here might be a reservoir that would accept a lot of carbon dioxide when we drill down to it and inject. And some of the other layers, let's say this green one here, would be shales or impermeable rocks that would help seal the carbon dioxide under the ground so it doesn't escape. When we're out on the plains, we've got the rocks are fairly flat lying. They might be folded a little bit and things like that over broad areas, but we can do a lot of injection out here. When we get to places like the Rocky Mountains and in many parts of British Columbia, the geological history has been much more complex. The rocks have been uplifted and folded and thrusted and things like that. And so the integrity of these rock layers is broken up. There's a lot of cracks, there's a lot of faults and potential escape routes for injected gases to the surface. So in fact, the Rocky Mountains themselves, even though they have great thicknesses of the same reservoir and containment rocks that are present in the plains, are not good places for either oil and gas production or for CO2 storage. Another great thing about the Plains area is that we've got hundreds of thousands of existing oil and gas wells in the Plains. And so we've got a very, very sophisticated understanding of the nature and distributions of the reservoirs that we want to drill into to store CO2. So speaking of those reservoirs then, here's an example of the actual reservoir rock that we would inject carbon dioxide into. And in fact, this particular sandstone reservoir is the one that exists at the what's called the Quest Carbon Hub project just northeast of Edmonton, and I'll show you that in a few minutes. It consists of a sandstone. So on the right side of the diagram here, what I'm showing you are sections of a core that's actually been extracted through drilling and recovery from the deep subsurface. This particular core was more than 3,000 meters deep. Originally, we've taken it out, we've cut it into sections that are about 75 centimeters long. So if we stack these all up, we're looking at about 4.5 meters of rock here. And you can see, from this very broad view that yes, it's fairly uniform. It is a sandstone. If I looked up close to it, I could see individual sand grains and I could see pore spaces in between those sand grains. And in fact, if I take a little sample, like I've indicated with the red square here, and I cut it from the core, I can mount it on a glass slide. I polish it up really thinly so I can actually shine light through it, put it under a microscope. This is what I get on the left. This is a thin section of that sandstone. And it's a very small field of view here. I've taken a picture through the microscope. So the red bar there on the bottom is just under a millimeter. So what we're looking at in this picture are individual sand grains in white. There are different types of grains, or either the mineral pyrite or some clay minerals that are in the green to black colors. But the key thing here are the blue spaces. So when I prepare my thin section, one thing that I do before I polish it up really thinly is I inject a blue epoxy into it. It helps hold everything together, and it also helps me visualize the pore spaces. So in fact, this rock, even though it was buried 3,500 meters deep under the ground, has about 10% or more open pore space. And those pores are relatively large and they're well connected in 3 dimensions. So it's got good permeability too. The fluids will flow through it relatively readily. This is a very high quality reservoir rock. And in nature, it contains either highly saline waters or it contains oil or gas. If I had oil or gas in this reservoir, it would produce those. We could produce those through a well at very high rates. By the same token, we can inject supercritical carbon dioxide into this reservoir at relatively high rates because of its high quality, good porosity, good permeability. So that's where the CO2 is going to go. And it's not only sandstones. There's other types of rocks called carbonates as well. So these rocks are basically the remnants of old organisms in the sea. And in fact, this particular carbonate, this big boulder stands out in front of the Geological Survey of Canada building, in the background there in Calgary. And it's a sample that was taken from the Rocky Mountains to the west. And what's really cool about this is this used to be a big reef, much like the Great Barrier Reef today. All of the big holes in here were reef-building organisms like the corals that are in today's reef, the ones back in the Devonian times, 350 million years ago, when this reef grew. They were called stromatoporites. Over time, they've dissolved out, leaving these great big holes in the rock. And if you take another thin section, just like the process before, you can see that even the solid rock where the holes aren't, between the holes, is formed of a mineral called dolomite. And there's lots and lots of pore spaces in the dolomite. And again, we've got a very, very high quality reservoir rock that will accept a lot of carbon dioxide. And in fact, this particular rock called the Leduc Formation is one of the primary targets for CO2 storage in Alberta. I mentioned containment of the CO2. So this photograph is an outcrop of a shale, the Horn River Shale, along the Mackenzie River in the Northwest Territories. Sorry, it's not the Mackenzie, it's a tributary to the Mackenzie. I can't remember which one. But it's really neat because you can see, I mean, here's hundreds of meters. There's a person for scale there, so maybe 2 meters high. So there's hundreds of meters of this shale. And if I cut a thin section of that shale, what I'm going to see here is that it's a bunch of clay minerals, it's a bunch of organic material, there's all sorts of stuff in here. But what you don't see is any of that blue pore space. There's virtually no porosity and there's no permeability. So it's a very impermeable rock. If the rock underneath in its outcrop is one of those carbonate reservoirs. So if I took this whole package here and I buried it in the subsurface, which in fact we find about 100 kilometers east of here, the carbonate could be a very good reservoir for injecting CO2, and the shale would be an excellent containment layer over top of it to keep the CO2 in the carbonate reservoir. Now, I mentioned enhanced oil recovery before. There are a lot of existing oil and gas fields in Western Canada and the Western US, for example, where we could inject carbon dioxide in an effort to improve the recovery of oil and gas. So, you know, a lot of these really high quality reservoirs naturally contain oil, but even if we produce them for a long time for a variety of engineering reasons, we usually recover only a small fraction, like maybe 15, 20, if we're lucky, up to 40% of the oil that's there. The rest stays in the ground. We can't get it out. But if we inject CO2 into those reservoirs, it actually can dissolve in the oil, can make it less viscous, it can make it flow more easily, and we can actually get more oil out from the reservoir while keeping the carbon dioxide in the reservoir. So enhanced oil recovery has been actually practiced for decades and is the sort of pioneering carbon storage technology that we've had and been working on for decades. A recent example in Alberta here is at the Clive Leduc Formation oil field. So the map on the left shows one of our primary carbon dioxide producing areas, the so-called industrial heartland northeast of Edmonton. And there's a bunch of refineries, upgraders, power generation and things going on here, lots of CO2 emissions. So many of the operators have got together to put their CO2, capture their CO2, and to put it into this pipeline. It's called the Alberta Carbon Trunk Line, and it's been built going south to just east of the city of Red Deer, which is over here, and that's where the Clive oil field is. And so carbon dioxide, about 1.5 million tons of CO2 every year, is pumped down the Alberta Carbon Trunk Line and injected into the oil pool. So a little schematic of the underground here. If you remember that carbonate rock, the big outcrop with the big holes in it that I showed you sitting outside the Geological Survey building, that's from this Leduc Formation. It's actually more than 200 meters thick. There's a huge volume of rock here. In the upper 20 or 30 meters of that sits this Clive oil pool, oil indicated in green. Oil naturally floats on water, and so that's where it is. And we can inject CO2 into that oil pool and get more oil out. Now, there is a lot more aquifer, or a lot more saline aquifer the same rocks but containing saline waters throughout the entire part of Western Alberta here, or sorry, Eastern Alberta. And in fact, what the Alberta government has done has designated a number of carbon storage hubs. So for example, one I'm going to show you, get back to in a minute, is the Origin project, which is within this big barrier reef of the Leduc Formation. There's that Alberta carbon trunk line coming down to it. But there are other carbon hubs that people are working on evaluating and planning for carbon dioxide injection as well. A couple that I point out is in green here, north of Edmonton, is the Shell Quest project. And since 2015, they've been injecting about 1 million tons per year of carbon dioxide into that sandstone reservoir that I showed you a few slides ago. And so they're up past 10 million tons total injected and continuing to move on very successfully. To the east, right against the Saskatchewan border, there's a big carbon hub called the Pathways Hub. And this is where all those oil sands carbon dioxide producers that are up north off the map here, they're planning to pipe their CO2 down to this area and inject it into that same sandstone reservoirs. They have to pipe it about 400 kilometers overall because geologically we've got this great sequestration reservoir, storage reservoir here in the Pathways storage carbon hub, but that isn't present further to the north. So there's no opportunity locally to inject CO2 from the oil sands. We have to pipe it southward. And this is the project that's being discussed by Alberta and the federal government right now about capturing and storing oil sands carbon dioxide as a condition to consider additional oil shipment capacity to the West Coast. Go back to that same map I showed you before with the industrial heartland, the Alberta carbon trunk line. And here, the Origins project operates side by side. In fact, the first well into Origins is only about 10 kilometers west of one of the main injection wells at Clive. But here, we're going into the saline aquifer. So this is naturally water-bearing reefal rock, as I showed you before, and they're injecting the CO2 into that big reef. Huge, huge capacity to store carbon dioxide. Now, I've showed you Alberta examples. Alberta is obviously not the only place where we can do carbon storage. In northeastern British Columbia, Geoscience BC actually commissioned a study a couple of years ago to map out the potential to inject carbon dioxide and store it in northeastern BC. In the Northeast, we've got our existing oil and gas production facilities, primarily in the Dawson Creek, Fort St. John, and areas north of that. And in fact, the hot colors here on the map show that there's very good capacity to inject carbon dioxide into saline aquifers in the subsurface through this area. We've got porous and permeable reservoirs. We've got lots of information from the oil and gas drilling about characterizing those reservoirs. So if we're going to do carbon storage in northeastern BC, this is the part of it that we would do. The other interesting area up to the northwest, near just south of Fort Nelson, this is the hot colors here are basically the old Clark Lake gas pool. Very similar aged rocks and similar types of rocks to those Leduc carbonate reservoirs. But up here, there's potential to do carbon storage. You could recognize the area because in exactly the same area, the Tudeh Ka geothermal project is operating, and they're looking to produce geothermal energy from the fluids that are in exactly those same rocks that could be the reservoirs to store carbon dioxide. Now, there's another approach to storing carbon dioxide in the subsurface, and this is of real interest in British Columbia, carbon mineralization. So the concept here is instead of just putting carbon dioxide into these fluid-occupied porous and sedimentary rocks, well, what if we find igneous rocks or volcanic rocks? And this is a picture of a basalt. from Iceland. It's just a sort of a nice example. And it's got pore space too. It's got empty spaces underground. There's fractures through which fluids can work. And the chemical composition of these rocks, it's quite reactive. In fact, they tend to react with carbon dioxide to form carbonate minerals, minerals that actually have carbon dioxide incorporated in their mineral structure. So wouldn't it be a great idea if we could inject carbon dioxide into these types of rocks through the pores and the fractures, have it react with the existing minerals, precipitate out as carbonate minerals, and thus guaranteeing that the carbon dioxide is going to stay stored underground for millions of years. It's a great concept. It does have a lot of engineering issues around it, but people are working pretty hard on that. And in fact, there's been research projects at the University of British Columbia and with Geoscience BC to quantify some of these landscapes in central BC where these types of rocks called ultramafic rocks crop out, trying to quantify, well, what can we do in terms of actually storing CO2 in these areas? And in fact, there's one project that I've been made aware of called CO2 Lock. They have a project area just southwest of Prince George. It looks like about 50 clicks or so southwest of Prince George. And they've mapped out the appropriate type of highly reactive rock that will form carbonate minerals, call them serpentinized ultramafics. And their proposal here is to drill an injection well to intercept a lot of these chemically reactive rocks along fractures, and that they'll dissolve the CO2 in water. It'll move out through the fractures, and over time combine with the minerals there to mineralize in the subsurface and storing the carbon permanently. It's a really interesting idea. There's a lot of engineering, financial, business challenges to it, but it does offer a really good alternative carbon storage mechanism in areas where we don't have the good sedimentary rocks that have high storage potential. A really important part of carbon storage is the monitoring and verification that the CO2 is actually staying underground where we put it. So as I mentioned before, we've got our reservoirs at depths, we've got our shales to contain them, and everything can go fine, but we've also put into place a lot of monitoring. For example, there are shallow groundwater wells where we sample the groundwaters to see if, for example, there might be any carbon dioxide leaking into those waters, something we don't want to see happen. Not particularly dangerous, but we don't want to see it happen. There's a variety of subsurface techniques, logging and geophysical techniques and so on, that can show us where the carbon dioxide is being stored underground and enabling us to pick up on any faults or leaks or anything that's going on. And one example of that, here's some maps taken from a time period going from 1999 on the left to 2008 on the right. This is in the Sleipner field in the under the North Sea off of Norway. This is one of the earlier sites where carbon dioxide was injected into an oil field reservoir. So back in 1999, they just started to inject at this point that they call injection point there. What the map shows is a geophysical or a seismic survey. And the survey responds to the fluids that are in the reservoir. And the more carbon dioxide that's in the reservoir, the more we see these blue and green and the red colors. And so what they've done is they've rerun this seismic survey every year or two from 1999 through 2008. And by 2008, what we see happening is that we've got an area here that's perhaps 1 kilometer wide and a couple of kilometers northeast southwest, where there's a substantial amount of carbon dioxide that has been injected into the reservoir and has stayed there. So this is a really good method of monitoring the performance of our CO2 injection. And what it can help us with, for example, is if we see discontinuities, like there's a breakdown in the south here and there seem to be some limits in the north, they're telling us, well, maybe our carbon dioxide isn't getting into those parts of the reservoir, and there might be something we need to do to make the process better. So seismic monitoring is an important part of just about every project that we propose. I want to wind up here in the next couple of minutes, just looking a little more closely at Canada. So here's a map that Natural Resources Canada has produced, just outlining all of the major CO2 emitters in Canada. So it's kind of a more detailed subset of that map of North America I showed near the beginning of the presentation. And pretty obvious that a lot of the CO2 emissions from Alberta associated with the oil sands and other oil and gas activities, but it does reach up into the oil and gas activities in northeastern British Columbia and the oil activities in Saskatchewan as well. Let's look at a couple of these areas in a bit more detail. So if we focus in Alberta, all these bubbles represent the big CO2 emissions arising from oil sands operations. So you'll remember when I showed the carbon hub map that they're planning to capture CO2 from all of these projects and pipe them southward into the carbon storage hub to the south there. So we've got, but there's a lot of emitters associated with the gas processing plants, with pipeline compression stations and things like that, that kind of mirror the activity of oil and gas in Alberta. Just check my notes, make sure there's nothing I missed there. Yeah. Okay. Well, let's look over in British Columbia. So in the Lower Mainland, we've actually got a substantial number of CO2 emitters, or in the area at least. There are some forestry mills on Vancouver Island. We've got a refinery in the Burnaby area. We've got some, what's the other thing? Oh, there's a Metro Vancouver waste to energy facility and cement plants as well. They're all major emitters in the Lower Mainland and surrounding areas. There actually is the potential for carbon storage in the Georgia Basin, which is a sedimentary basin that underlies the Lower Mainland, part of the Strait of Georgia, bits of Vancouver Island and the Southern Gulf Islands. And so there's actually a study being spearheaded at Simon Fraser University to understand the potential storage capacity for CO2 in the Lower Mainland area. Now, the technical assessment is one thing. Obviously, I think that if an operator or even the government comes in to propose that we store CO2 emissions from the Lower Mainland area by drilling wells into that Georgia Basin somewhere in the Lower Mainland, there's going to be people that have issues potentially with that, and are going to need a lot of comfort that these operations can be carried out safely and reliably. Another area I want to point out is Southern Ontario. Of course, here in Southern Ontario, we've got big refineries, a lot of industrial plants, a lot of cement plants, some natural gas power generation, things like that. So a big concentration of CO2 emissions in Southern Ontario. Now, there's been a bunch of work done to demonstrate that there is some sedimentary basin carbon storage capacity in southernmost Ontario along the northern shore of Lake Erie. All fine and good, but it really isn't enough capacity to take all of this carbon dioxide. We've got other emitters further down the St. Lawrence in eastern Ontario and into Quebec as well. And in fact, if we want to store the carbon dioxide from those major industrial point sites, we may need to build a much longer carbon dioxide pipeline and actually pipe all those emissions out to the East Coast and re-inject them into places like the Scotian Shelf. If you remember, back in the 90s and through to about 2018, there was a lot of natural gas produced around Sable Island off of eastern Nova Scotia. There are fabulous, fabulous sandstone reservoirs there that have massive capacity to hold carbon dioxide. And in fact, Natural Resources Canada is right now sponsoring a geological and engineering study, which my company is participating in, to understand the capacity to store carbon dioxide there. But the big prize for that area would be all of these emitters in Ontario and Quebec, not so much the lesser emissions that we see in the maritime provinces. Overall, we're seeing that with time, the capacity to capture and store CO2 globally is growing. You know, back in the early 2010s, there was in green here some small capacity, maybe 10, 15 megatons per year of storage potential, or storage that was actually happening, mostly in the North Sea and places like that. There were a number of projects being built in the brown color, some that were being in advanced stages of development in the dark blue, and some that people were really just talking about in the light blue. As we went into the 20-teens, we saw a little bit of growth in firm capacity, but all of the early development stages they kind of went away. Economic conditions, operators were not sure of the types, of how they would get paid for storing carbon dioxide, or who would pay for it. And so interest kind of waned. But within the last 5 years or so, we can see that there's actually been a lot of capture storage capacity in operation. So now we're up around 60 million tons per year of storage capacity. There's a bunch more being built that would take us up above 100, and then a huge number of projects under consideration. And the Alberta carbon hubs that I showed you a little map of would be within this dark blue, and maybe a couple in the light blue part here. But we're looking now at more than 500 megatons per year of carbon capture and storage capacity that's at least being considered. And compare that to, if you remember back to the graph I showed from the International Energy Agency, they were talking about upwards of 7 gigatons, or 7,000 million tons per year by about 2045 capacity. So we've got a lot more work to do if we want to reach the capacity that they foresaw for carbon storage. But we're well on the way. Let me sum up then, just review a couple of the thoughts I've shared, and then I'd be happy to engage in any discussion. So the human production of CO2 is relatively small, but it does disrupt Earth's carbon cycle. And so atmospheric greenhouse gases, including CO2, are increasing and are a concern from the point of view of climate and other effects. We can actually reduce our net production of greenhouse gases by capturing and storing the carbon dioxide instead of allowing it to flow into the atmosphere. And we want to focus on the very high concentration, or the industrial point sources, the power generation stations, the ethanol plants, the cement plants, the refineries. We can take CO2 from very high concentration streams there and store it underground. Direct air capture is something that has research going on, but it deals with very, very low CO2 concentrations, and it's inherently going to be a lot more expensive and difficult than these high concentration facilities. We've seen there are many porous and permeable reservoirs in sedimentary basins, and we've learned about their characteristics and their distribution through oil and gas drilling and production activities. We have been, for a number of decades, injecting some amount of carbon dioxide into oil reservoirs for the purpose of enhanced oil recovery, chasing more oil out of the reservoirs while keeping the CO2 underground. We're looking much more now at injecting that CO2 into saline aquifers, or high quality reservoirs that naturally contain saline waters. And in fact, I didn't mention, but that Leduc reservoir rock that at the Origins project, where I showed the injection just starting, the water that's in there naturally is about 10 times as saline as seawater. So nobody's going to mind too much if that saline system is disrupted a bit by adding some CO2 to it. There's also the potential for carbon mineralization in basalts and other so-called ultramafic rocks. We're really at a research and development stage there. But the exciting thing about carbon mineralization is it offers opportunity to do carbon storage in areas that aren't blessed with a whole bunch of sedimentary rocks and great quality reservoirs. Monitoring and verification of existing carbon dioxide injection schemes is critical and is included in all major projects to ensure performance and safety, making sure that we keep the CO2 where it belongs and not allow it to leak to the atmosphere or to groundwater. And just to reiterate the point again, as said before, Canada is truly a leader in carbon capture and storage research and implementation. We've got the great knowledge from our oil and gas and from our mining industries about where to store carbon dioxide. We've got the industrial infrastructure, we've got the geoscience and engineering knowledge, and we're moving forward. So thanks for your attention. I'd be more than happy to, if we've got some time, to entertain any discussion or questions. I'll stop sharing here.
Well, Brad, thank you very much for that. I mean, really informative presentation. I have to say that you're a gifted presenter. You've taken a complex topic and made it understandable and presented it in a way that we all can get information from. There's a lot of information in it. Will your PowerPoint be shared?
I can certainly do that. I'll send you a PDF version of it because it's pretty big.
Okay, thank you very much. Yeah, so any questions or comments from anybody?
I think there was the one question in the chat there, Peter. Have there been underground assessments done around the province that show where this would likely be feasible or less likely?
Yes. So my company did a project for Geoscience BC a couple of years ago, and we looked at assessing what's called the Nechako Basin in central British Columbia. So in the general sort of Williams Lake, Anaheim Lake area there, quite a large chunk of countryside. And we concluded, unfortunately, that the potential for CO2 storage in that part of the world was just very poor. There's a lot of volcanic rocks at the surface. We don't understand the deeper subsurface very well. There's been 12 or 15 gas exploration wells drilled in the area over the decades. And what it shows us is that the reservoir rocks are not very good quality. There's a lot of fracturing of the rocks, a lot of structural deformation that would make us concerned about the integrity and the ability for containment to be really, really good. So that central area is just not very good. The assessments that have been done that show a good potential are that one that I showed you the map in northeastern British Columbia, the Canadian Discovery did, and then my understanding is that the Simon Fraser work in the Georgia Basin demonstrates that there's a lot of potential storage capacity there. So those two areas, the Georgia Basin, Lower Mainland, and northeastern BC, are where we see good capacity. There have been a couple of assessments done elsewhere that demonstrate poor capacity, and for what we know of the geology regionally, there's not much point in doing other assessments because they just don't, there's just not the potential there.
Thank you, Brad.
So, Brad, I just have a question, if I can, is your graph on CO2 concentrations showed it just kept getting steeper and steeper. And is it the case that it continues to get steeper and steeper, or is it kind of, leveling off?
I think that I think that it's not leveling off yet, but the rate of increase is, it's not, it's staying steep. It's not getting steeper as quickly anymore because we are starting to turn the corner a little bit on emissions. But in general terms, as long as we keep emitting more CO2 every year, which we are still doing on a global basis, then it will continue to climb pretty steeply.
Thank you.
Yeah, and that's and I think there'll be some lag too, right? I mean, if you level off and start to actually decrease the amount of CO2 emitted by humanity on a global basis, it'll probably take I don't know, a couple of years, 5 years to show up in the atmospheric concentrations. I'm seeing in the chat, I believe, a note from Caleb talking about subsurface pore space. There is the BC Energy Regulator is in charge of subsurface pore space for both oil and gas and for the right to sequester carbon dioxide in the subsurface. And so they have very deep industry knowledge, and I think are very good administrators of and regulators of that pore space. There are definitely complex issues around that, and I mentioned at Fort Nelson that Devonian Reef, the Clark Lake Reef, that used to be a really big gas pool. There are operators looking both to inject, to store CO2 there, and the Two Day Ka project that is looking to do geothermal energy generation from that same reservoir. And so the BC Energy Regulator is challenged to be sure that the activities that both operators might want to do aren't interfering with each other. One operator has the right to inject CO2, the other operator has the right to produce hot water and extract geothermal energy. But they're both working with the same rock and the same fluid, so there are the potential for conflicts. So Caleb's question is one that needs a lot of thought. It just from a geological point of view, let alone the First Nations jurisdiction issues that he raises.
Thanks, Brad. I think there was one question there from Andrea about where the assessments can be found. I see there was a few answers to that, but I was wondering, is that all of them, Andrea?
Yeah, I see there's some links here by Alex Curry. Yes, the CCS Atlas completed by Geoscience BC. I showed the one map from that. That's a very comprehensive publication. I think he's pointed out the Chaco Basin one I was talking about, the Central Interior Geological Carbon Storage Assessment. That's another Geoscience BC project and I'm the lead author on that one. The Northwest BC geothermal CCS assessment, I'm not as familiar with.
Yeah, Brad, would you happen to know, that's a lot of information in these resources here. Some of them may be a little too technical and for lay persons. I wonder if there's a resource that has a summary or executive summaries of these documents that is out there.
I'm not sure whether there has been I mean, the documents have executive summaries, but they're very short in terms of a summary that actually is, perhaps a plain language review of what each of the studies mean. I'm not aware of something that exists. Unfortunately, geoscience, I think it would be something that Geoscience BC would be very well suited to do, but unfortunately they're having funding issues. And so I don't think they have a capacity to do that right now. It might be a question to ask of the BC energy regulator as to whether they've got any summaries that they've produced. It's also the type of thing that I do. Like, I like doing these sorts of presentations, and if the regulator or the First Nations wanted to engage me to do that kind of summary, I'd be happy to take a shot at it.
Oh, thank you. That's good to know. Any additional questions out there before we head for a break?
Hey, Peter, it's Paul here. Sorry, I couldn't figure out how to raise my hand, but yeah, Paul Blum from the First Nations Energy Mining Council. Thank you for the presentation. I have a question, because about 8 years ago, a leading climate scientist in British Columbia said that carbon capture and storage would never happen. It was pie in the sky. That was the words he used. Mm-hmm. What changed in the technology to make this happen? Is there something specific that you can point to as an example?
No, there's nothing to point to, and quite frankly, I don't think that particular person was correct ever. I mean, you saw, for example, in my presentation that the Norwegians have been successfully injecting carbon dioxide beneath the North Sea since the 1990s. It's not pie in the sky. Enhanced oil recovery storage has been happening for decades. I've seen a lot of media and online things that talk about alleged poor performance and things like that. And most of them, I'm afraid, just aren't very accurate. I think the big question is whether or is around the economics and the business case for it. It takes considerable energy, and it costs a fair bit of money to actually capture CO2 and to inject it, store it underground. So that's absolutely a valid concern. It doesn't mean that it's pie in the sky or anything like that, but it does mean that every time we look at assessing the potential to do a CCS project, we have to look at not only at the technical aspects, but at the business case and the financial aspects. Are we getting the best bang for our buck in emissions reduction with a CCS project as compared to other things we might spend our money on?
Thank you.
You can see probably, Brad, a couple more questions in the chat.
Yeah. Ron must be a very good typist. Holy smoke. I'm just going back. I'll try to pick out a couple of things that I feel qualified to address on here. Obviously, the consultation requirements and so on are not my expertise at all, so I won't venture anything there. The environmental risks and impacts. So I'm seeing a question here. What are the specific potential environmental risks of CCS within our traditional territory, e.g., groundwater contamination, impacts on habitats from CO2 plumes, and that goes. So in general terms, that goes back to the design of carbon capture projects and the monitoring and verification. There's been one well-publicized failure of a carbon storage project, I believe it was in Illinois, where they actually detected some leakage from the sequestration reservoir. And I think it might have got up into groundwater. So the answer is there is always a risk when you undertake industrial activities that there will be some environmental impact. Now, the environmental impact of leakage of a carbon dioxide storage reservoir is that you would slowly leak carbon dioxide back up to groundwater to the surface. Now, it's not like you're leaking oil or natural gas, which would be, toxic or contaminant. Carbon dioxide is, say, it's in our atmosphere. The real risk there is not so much environmental as it is wasting time and money in injecting CO2 and allowing it to leak out again. But the whole point of the sophisticated evaluation of containment and then doing the monitoring verification afterwards is to both minimize environmental or technical or financial risks associated, and then if something actually does leak, understanding where and why and how to remediate that problem. How will the proponent ensure the long-term integrity of the CO2 storage reservoir? Will the monitoring systems be in place for thousands of years? I think the most practical answer here is that at some point, the monitoring systems that are put into place will need to be administered by the regulator. In BC's case, the BC Energy Regulator, in order to ensure the technical merits and competencies and that things are being monitored correctly. Obviously, I can't tell you what's going to happen thousands of years from now, but right now, the project proponent, the actual operator of the facility, is responsible for the monitoring and verification. At some point, say once you've gone, say, 50 years, injected all the CO2 you're going to inject, there will be monitoring systems left behind that we'll have to figure out who's going to be responsible for them, likely the regulator. What's the realistic risk of a CO2 leak into groundwater or atmosphere? Very, very low. Let's just say there's one example right now where they probably cut some corners where there's been some leakage. I can tell you from the assessment projects that I've been involved with that there's an immense amount of work done to ensure the integrity of containment. And the real proof in the pudding is that you're injecting carbon dioxide into reservoirs that for millions of years have contained oil and or gas and highly saline, to the point of being toxic, water. And none of that material has escaped over millions of years. Injecting carbon dioxide into those very same pore spaces is highly unlikely to change that, as long as we do our job properly.
Peter, I do see Patricia has her hand up for a question there.
Okay.
Thank you. And thank you, Brad, for the presentation. It's very useful to understand carbon capture. Yeah, I have a couple of questions. One was about the effectiveness of this technology, and Paul kind of, bring that when he talked about this person who said that carbon capture was not possible. So and you also mentioned that this technology, there are projects since the 1990s. So I am curious about how effective is this? Because the technology is not that old, right? So how many examples you have around the world that where we can show this technology is effective and is really having, the data that can show that is being successful? That's one question. The other was actually around the environmental and monitoring aspects that you kind of addressed. But a follow-up question maybe it's that what is the role that you see of First Nations in this new business and technology development? What's the role of First Nations in the during the life cycle of the project, thinking not just around investments, but also in monitoring and all these other aspects of the project for the long term. And finally, maybe you addressed this in the presentation, maybe I didn't catch it, but I want to know what's the life cycle of this. What's the end of the life for those type of projects? So how much they will last, I would say. Thank you.
Let me take the last one first. The life cycle of projects really depends upon their performance and the size of the reservoir. I think that it would be reasonable to expect projects to probably, they're going to be long lasting. They're going to be 25, 30, 50 years or more. Many of these carbon hub areas in Alberta and the big area in northeastern BC that you saw on the map there, excuse me, in the hot colors, those are very, very big areas with massive capacity. And you could drill a couple of wells, next year that would store all of the carbon dioxide produced in that particular area and captured on a yearly basis. And then maybe 20 years down the road, you would drill another well a little ways away to continue to inject the CO2. So they can be very long-lived projects because the underground reservoirs are very substantial. In terms of your first question, global projects and the success that's happened, I think that graph I showed towards the end shows that we've got now more than 50 million tons of storage capacity that's working, 50 million tons per year. The one project I pointed out called the Quest project near Edmonton has been safely and to specs injecting 1 million tons per year since 2015. There's going to need to be a lot more of these projects. There is a report, if you want to Google the Global CCS Institute, they produce a report every year, and I think they've got a 2025 report that I have here somewhere that reviews all of the existing projects in the world, shows where they are, what their capacities are, and their performance so far. So that's a really useful report that shows what's going on currently. Again, I'd like to emphasize that if we're going to reach the goals for carbon storage that are outlined in things like the International Energy Agency net zero report, we're going to have to build a lot more of these projects. With respect to the involvement of First Nations, again, that's kind of on the edge of my knowledge, but I really think that, I'm aware that there's been a lot of evolution of First Nations rights and involvement in the oil and gas and mining industries in British Columbia over the last few years. And I would expect that First Nations involvement in carbon storage projects would parallel their involvement in current involvement in industry. I mean, we're talking about drilling wells, the same types of wells into the same places, the same reservoir rocks with the same jurisdictional rights. So I would imagine that there are probably opportunities, if they are financially attractive, for significant First Nations involvement. But say that's kind of as far as my knowledge goes on that. So I hope that addresses some of your questions.
Oh, thank you again, Brad. Any more questions there before we think about taking a break?
Yeah, I had a quick question just building off that last one. So to hear you tell it, and maybe I'm misrepresenting what you're saying here, but are you kind of looking at this sequestration model as a reverse oil field, where instead of pulling it out, got a similar pattern in different areas in order to put the carbon under?
I'm sorry, you're breaking up on me a little bit. I didn't hear the last couple of sentences.
I'm just saying it sounds a little bit like what you're proposing here in terms of this carbon sequestration kind of well siting, put in a well on location on a section and then move to another area and drill another well and start putting carbon in to the ground in that section. Seeing a lot of similarities between like oil and gas development, where it's the inverse, where you're going to those reservoirs, pulling out the resource and in. So we're looking at a land base that has a similar industrial development pattern. This carbon.
Yeah, exactly right. And it's not, we're not even, this isn't the first example either, really, because there are existing enhanced oil recovery operations in northeastern BC. I'm not sure if anybody's injecting carbon dioxide, but many, they're injecting natural gas or they're injecting water to help recover more oil. And then there is also regulated by the BC Energy Regulator in those same regions, a number of water disposal wells where water that has been produced from gas wells or is left over from hydraulic fracturing operations is injected into those same subsurface reservoirs. So a lot of the geoscience and engineering that we understand around injecting wastewater is very applicable to figuring out the best ways and the best places to inject carbon dioxide.
Okay.
Does that address question?
Yeah, I think it does, and I appreciate that. I'm looking more at I guess a surface level impact, and so with all those different injection wells, we're kind of adding an additional well footprint to that landscape of both extractive and kind of insertion wells.
Yes, but I believe that the footprint of the CCS projects, the number of wells and so on required, are going to be far less than the footprint of what we're seeing happening now. The other thing I might mention is let's not forget the potential for carbon mineralization. If for example, CO2 Lock can make their carbon mineralization project economic, then we might see a drill rig in southwest of Prince George where we haven't seen one before in order to inject the CO2 into those volcanic rocks and fractures and so on.
Right.
Brad, just a following question on that. Is there any example where the project have closed? Like what's the next steps for after the closing? Is monitoring is required? Who is doing that monitoring? For how long? So what happened after the 25 or 30 years with that facility and the project, and who is or if there is leakage, how do you manage that?
So just so I make sure I understand you clearly, you're talking about what happens after a typical carbon storage project is done, say 25 years down the road.
Yes.
So in keeping with the last conversation, it would be very, very similar to oil and gas operations, where there would be regulations about how the infrastructure, particularly the wells that are doing the injection, would have to be, technical term for it is abandoned. In other words, how we would have to treat the well bores to ensure that they maintain their integrity and leakage doesn't happen. And that usually involves a process of injecting a lot of cement and different seals into the well bores and then plugging them off at the surface and say restoring the site to its original condition. The monitoring, to ensure that we don't see some carbon dioxide starting to leak, let's say 20 years after the last was injected, we would maintain some of the monitoring network. So for example, if there were shallow groundwater wells drilled around the storage site, they would continue to be monitored or tested periodically to ensure that there's no carbon dioxide leaking into the shallow subsurface. So I think, again, we've got a pretty good regulatory framework in British Columbia to ensure that these types of operations are, say, properly put to bed to minimize future risk. We would want to, I think, review those specific regulations to make sure they fit the CO2 injection operations really well. But the BC Energy Regulator is a very, very highly competent group, and I'm quite confident that they would ensure things were shut down and monitored appropriately.
Is there any example in the world that we have a project that has closed and they're in this phase of monitoring? Do we have data about that to understand what are the potential impacts, or it's everything is theoretical now?
We do have projects where there is monitoring and so on. They're not in British Columbia. So, for example, that Quest project in Alberta has been operating since 2015, and there is a network of monitoring and verification, excuse me, shallow wells there, plus some of the other tests that I showed in that schematic diagram. They may be running those seismic surveys to illustrate where the CO2 is in the subsurface, but I haven't seen them. But at any rate, there are existing projects where we can look at how the monitoring and verification has taken place over time. And in fact, I think I did mention the one project that I'm aware there's been an actual problem with, or a failure in Illinois. It was detected through shallow monitoring wells. I really don't know any details about that, but so there's data associated with the one known failure, and there's data associated with the pools that are being injected now. But say we don't have any that's directly in BC because we haven't done any CCS projects in BC yet.
Just to follow up to that, Brad, is earlier you mentioned that if there was a leak, then it's kind of like, okay, so we weren't successful in storing the CO2, and if it leaked into a groundwater aquifer, as I guess it did in Illinois, so it doesn't contaminate the water?
If it went on long enough, there could certainly be carbon dioxide dissolving in the water. Which would increase the acidity of the water. I don't think would ever get to the level that you'd have, let's say, carbonated water, like a cola or something like that. But yes, you could get carbon dioxide dissolved in the water. Now, likely, what would happen if that was groundwater and you produced it to the surface where the pressure is only atmospheric, most of that carbon dioxide would bubble out right away, but it could become more acidic. Either way, it's not something that you want to see happening. I guess my point was, it doesn't make the groundwater toxic. It makes it a little bit more carbonated. Probably, and I think this is the case in Illinois, the main risk in the integrity of these deep reservoirs is if there's an older pre-existing well, let's say an oil or gas well, that was drilled to similar depths, and then perhaps it was abandoned, let's say 50 years ago, because gas drilling in northern BC goes back to the 1950s. let's say that old well didn't have very good cement, or it wasn't abandoned to today's standards, or it's deteriorated over time. It might be that carbon dioxide could leak up that particular well bore and get to the surface, or potentially even into shallow groundwater. But with proper monitoring, that's where we would locate that leak quite quickly. And if that's the case, that CO2 is leaking out of an old well bore, well, you can quickly go in and address that issue by, say, putting more cement and abandoning the well bore according to how the reservoir engineers tell you it needs to be done.
Hi, Brad. So you're playing a bit of ping pong here with these questions, but based on that, and when you look at the pattern of abandoned wells, oil and gas industry all across Canada, and some of the challenges with keeping those, finding someone to foot the bill to do that capping in the event of a leak. Going back to my earlier question about the surface impact of the pattern of development for this, you have, like you mentioned, you're not needing as many of these wells as you do to extract the oil. Is there like, I guess, a metric around, you can build a well that puts in X amount of CO2, and that will fill up a reservoir of X amount, and surface footprint to do that is high, compared against oil and gas development pattern?
So in northeastern BC, we're really talking about relatively small amounts of CO2 that could potentially be captured and stored. We don't have the great big oil sands or big refineries and things like that emit so much CO2 elsewhere. So the kind of limiting factor for the actual storage development in northeastern BC would be the actual amount of carbon dioxide available. So as a kind of comparator, that Quest project near Edmonton injects 1 million tons of CO2 per year in 1 or 2 wells. So let's say that in northeastern BC, and I'd have to go back to the report, but let's say there's, 50 million tons per year of carbon dioxide available for capture and storage. You'd have to drill then maybe 50 to 100 wells to actually do the injecting and the storing. The bigger footprint than the wells would probably be the pipelines that you need to build to take the CO2 from the locations, let's say the gas plant or the forestry mill or whatever that's producing the CO2, the pipeline you have to build to go from the collection point to the injection wells. So, I don't want to trivialize it. It's not minimal footprint, but it is a relatively small footprint compared to what we've already got with the existing oil and gas industry, because there's really only a certain amount of CO2 that's available for capture and storage.
Thank you.
Yeah, thank you, Brad. There's a question in a comment there, Brad, if you want to have a look.
Let's see here. Oh, okay. Are there any chemicals beyond CO2 that we use to store carbon? I'm thinking, for example, the use of condensate to make diluted bitumen flow through pipes. Is there anything that needs to be mixed with CO2 to move or store it that would end up being pumped into the ground and stored? Generally, no. If you remember back to the little schematic of the capture and pipelining of CO2, when they capture carbon dioxide at the cement plant or whatever the facility is, they actually compress it right away to supercritical conditions. And so it occupies relatively little space and it has very, very low viscosity. So it flows very easily. As you point out, condensate is used to dilute bitumen because dilute bitumen is very, very thick and viscous. So it needs help to flow. But CO2, you compress it, make supercritical CO2, there's probably nothing that flows more easily. So you're injecting only CO2 into the ground. And in fact, one other thing that was on that little figure you might not remember is that they dehydrate the CO2 first. What they want is absolutely pure CO2 to move and store.
Great. Yeah. Thank you, Armini. Thank you, Brad. So any more questions out there? It's 1:45. We're scheduled to be back at 1 o'clock. So it's probably now's a good time to take a break. I think. Thank you again, Brad. And I can't help but notice that the supercritical CO2 when it in your air is 100 volume, and then that gets compressed down to 0.25. When it's subsurface, it kind of reminds me of my bank account. When I take money out, I only get about 0.25 of the volume that I take out. So
It's
anyway,
amazing.
thanks everybody, and I reckon we'll sign back in at 1 o'clock. I see there's just one more comment there, Brad. Patricia says, but we can admit that this technology with almost no cases that can really provide a systemic analysis of the footprint.
I guess I
Yeah.
suggest that there are, if you want to go to other jurisdictions like Alberta, like Norway, and so on, you can do that sort of analysis. It has not been systematically undertaken at this point for northeastern British Columbia or for the lower mainland area, the Georgia Basin area. That would, we would need to build on the analyses we've done so far to come up with some numbers and areas and so on for that.
Okay, good.
Great.
We'll thank you very much again, Brad, and I guess we'll sign off and come back here for 1 o'clock.
Thank you. Bye now.
Thank you.
You can do the bypass, you can go on a tree and you can push it up. Not very tension. It's a problem with the sand drum, right? Because if we use the tree trucks or side trucks we use, we can't go with the bypass. Last time we got a problem.
Yeah, hello everyone. It's 1 o'clock, so we'll get back going again. We're happy to have um, Robert Phillips join us this afternoon. He was tied up this morning with some important work and is able to share some remarks and some comments with us here today that could have been done this morning, but again, he was a bit busy. So, Robert, if you're there, could you go ahead? Thank you.
Hello, Wade Chukwinuk, Scotland. As mentioned, Robert Phillips with the First Nations Summit. So we literally just came out of our debriefing, and my apologies for not joining you this morning. But we did have a leadership council and a premier meeting and prep meetings prior. And because of that, around the DRIPA, the Declaration Act discussions, we just could not leave that meeting. But I wanted to acknowledge the Musqueam, Squamish, and Tsleil-Waututh because I'm coming to you from Vancouver, and recognize as well the chiefs and leaders and elders and many of the technical teams that are air and experts and industry representatives and as well government, our partners in government that have joined to have this important discussion. And I know Leah provided opening remarks this morning as well. Appreciate the work. She was actually chairing our meeting, left, but I couldn't leave. So sorry for missing that. So on behalf of the First Nation Summit, I thank you for participating in this conversation around carbon capture, utilization, and storage, or CCUS. I guess I can call it CUS. But anyway, and what it means for First Nations in British Columbia. It's an important dialogue because it's not just about technology. It's not just about carbon markets and not just about emission targets. It's about our lands. It's about jurisdiction, and it's about what the big topic nowadays is around, economic self-determination. And we know we're in a Trump era, and we know we're talking major projects and agreements across British Columbia, Canada, and internationally. And we know we're in this different era, it does seem. And but it's about First Nations that will play an important future in terms of not only resource development in this province, but the climate policy and the climate crisis that we're in and what we have to do about it. For many of you, and for many of the government's climate change is about, it's about measuring its reports and targets. For First Nations, it's a lived experience and reality. And it shows up in, what we've seen so much now that has become normal. At one point, it was, this is a one-off. This is the worst it's ever been. But it just seems to happen year after year now. And forest fires affecting our territories and our communities. We just have to, look at Lytton literally burning to the ground, changing summer runs and disrupted ecosystems, and flooding and extreme weather events. The return of Samathatsa, Sumas Lake. And I was living in Abbotsford at the time, and it was just, a sight to behold, the return of that lake because of all the flooding and extreme weather. And the impacts to our cultural practices and the food systems. Our nations have been stewards of these lands since time immemorial for thousands of years, and we understand the ecological balance. We understand sustainability, and we understand the responsibility for future generations. And we speak about carbon management, and and coups, we are not entering a new conversation. It's something that's continued and been part of our ancestors and our oral history now for thousands of years. And again, I emphasize it's a lived experience. So in BC, Canada, and the global community, we're pursuing aggressive emissions and reductions targets and industrial sectors, oil and gas, cement, steel, mining, LNG, and we're under pressure to decarbonize. And some of these sectors operate directly or adjacent to First Nations territories. And coups is entering as one of the primary tools government and industry are proposing to meet these targets. And there's so many questions. And that raises fundamental questions about, where we're at with carbon, that it be captured, and then where it will be at in terms of transported and stored, and the again, so many questions around benefits economically and the long-term responsibilities. And the answer to these questions must include, though, First Nations. And again, to emphasize, not as stakeholders, but as right holders. First Nations are central. We need to be at the table. We're not at the peripheral. And let me be clear that it's not viable for a CCUS strategy in BC without First Nations. And why? It's because geological storage, the permanent sequestration of carbon dioxide occurs underground. And all these underground formations sit beneath our territories. And many of the most promising sedimentary basins in BC are in areas where First Nations have strong title, treaty rights, and inherent jurisdiction. And international law, including the United Nations Declaration on the Rights of Indigenous Peoples, affirm our right to control, develop, and benefit from the lands, territories, and resources that we've traditionally owned and used. The CCUS policy must align with those principles. Free, prior, and informed consent. Not only meaningful consultation, but FPIC is not an option. It should be the foundation. From environmental liability to economic opportunity, carbon is currently treated as a liability. But when captured and stored, it becomes part of a value chain, and this creates potential for long-term storage, service revenues, infrastructure partnerships, equity ownership in projects, participation in carbon markets, integration with clean energy projects like geothermal and hydrogen. For First Nations, this represents a new economic frontier. It's structured, if structured properly. We have seen what happened without meaningful First Nations participation. And if I may call it coups, may not repeat that history. Instead, it can be a model of co-development and shared governance. And the importance of getting it right, that there are legitimate concerns around CCUS. And we must ensure environmental integrity, long-term monitoring and liability clarity, transparent regulatory frameworks, respect for cultural and ecological values, and meaningful community engagement. Costs cannot be used as an excuse to delay the transition away from fossil fuels. It must be a part of a broader decarbonization strategy that includes renewable energy, electrification, conservation, and innovation. First Nations leadership will be essential in setting these guardrails. So again, like what we're seeing in the discussions I just had around DRIPA in terms of co-development and governance, if coups is to move forward in BC, several principles must guide it. One, recognition of title and rights. Projects must respect inherent and constitutional rights. Two, shared decision-making. Regulatory framework should be co-developed for First Nations. Three, economic equity. And this is so important in terms of economic equity. First Nations must have access to ownership, revenue sharing, and employment opportunities. 4, long-term stewardship, monitoring, and liability must not be imposed without consent or capacity. 5, capacity funding. Nations must have resources to access technical, legal, and environmental implications. This is not simply about consultation. It's about partnership. And of course, British Columbia has the opportunity to become a global leader in responsible carbon management. But leadership requires collaboration. It requires trust, and it requires recognizing First Nations are not obstacles to climate action. We are essential partners in it. Our stewardship, our knowledge, our governance systems, our commitment for future generations brings strength to this work. So we give a call to action. Today's webinar is part of building shared legacy and understanding. And we hear from, again, what we've from our experts, from our geologists, from our government representatives and partners, and from First Nations leadership. It is the ultimate goal is not just information. It's about aligning. It's about a strategy. It's something that is very important to be part of BC's climate pathway. First Nations are shaping it, and in the beginning, and not just reacting to it. So I say to all of you in closing, climate change demands bold solutions. Bold solutions must also have a way to where we get to not only action, and the funding that is necessary for us to do that work is very important as well in order for us to do it properly, to reduce emissions, to support economic development, to create true partnerships, to reinforce Indigenous leadership in climate governance. If done improperly, it risks repeating past mistakes. The past 150 years has been very difficult here in British Columbia for First Nations. And the path we choose will depend on the conversations that will happen here today. And I look forward to a thoughtful, respectful, and forward-looking dialogue, and appreciate the opportunity to speak to you. And again, apologize for missing this morning, but I give you a big kuksjam. Thank you very much.
Good Robert. Thank you for those words, and also thank you for your work this morning with BC. That's vital work for all of us, and certainly, as you say, we don't want history repeating itself with First Nations being pushed off to the side. So again, Gunishish. Next on our agenda for this afternoon, we have a couple presentations from BC government and from Canada. First, we'll have Genevieve Saint-Denis along with Cassidy Nindrick. Genevieve is a director at, BC, director at the BC Ministry of Energy and Climate Solutions. Her and Cassidy will do a presentation, and they'll be followed by Alexander Curry, who's with NRCan. Going to take it away, Genevieve and Cassidy.
Thank you so much for that introduction. And thank you, Cassidy, for navigating the slides for us today. So yes, my audio is working okay for everyone? Seems like it? Okay.
Yes.
Thank you for the introduction. Like I said, I am the Director of Regulatory Policy here in the ministry. I work in the Energy Resources Division, and so we cover topics such as CCS, but also oil and gas, as well as geothermal and helium, hydrogen, should those become a little bit more prominent in our province. Before I begin, I'd like to take this opportunity to acknowledge that I am grateful to live and work in the territory of the Lekwungen peoples. So that's today the Songhees and Esquimalt nations. And I thank everyone in the audience today for joining us, and to FNEMC for hosting this event. So I am going to keep my talking time brief so that I'm available for questions. And I have brought with me a few of my colleagues from the ministry to help with those questions as well. We kept our numbers very small, so if you have specific questions that would be actually better for the BC Energy Regulator, we will take those back with us and contact with them since they are not on the call today. So I will start off with my first slide here about our CCS regulatory framework. And as you can see, we've put up this colorful diagram to really demonstrate that our regulatory framework covers the entire span of the development process for projects. So that's with, starting at a tenure phase for exploration and continuing right through to the actual development of a project to the post-closure phase. Through this framework, we have very clear rules about how underground storage is acquired, how permits are issued, and how projects are monitored throughout this entire life cycle. The key part of these approach is to focus on the measurement, the monitoring, and the verification. These requirements are in place to ensure projects do not create an adverse impact and that the injected carbon dioxide remains securely stored for long term. And I'm talking about geological timeframes here. So as shown in the colors here, there are multiple steps that the regulatory framework covers. Proponents, they need a tenure to even start exploring. And while exploring, they need permits for those. So what I wanted to highlight on this slide is that the tenuring process that happens throughout the project life cycle is issued by the ministry. And the tenure process is regulated under Part 14 of called the Underground Storage section of the Petroleum and Natural Gas Act. And then it's the BC Energy Regulator that issues the permits for CC activities under ERA, so the Energy Resource Activities Act. And so those permits would cover exploration, but also then development of a project, operations, closure, and the post-closure periods. So then we've shown in the blue line, the blue pale line arrow that you see there, that throughout the project lifecycle, operators hold project liability. And by that, we mean they remain responsible for the safety and the integrity of their sites, including any incidences, leaks, et cetera. So for further information about a regulatory framework, we do have some guidance documents, which we've linked here, and we'll make sure that these slides are accessible after our presentation today. So now I'm just going to go through another slide about Indigenous engagement in CCS projects. So on this slide, we've listed the elements that describe at a very high level the engagement and consultation processes involved in CCS projects. So for CCS projects, engagement really starts with the proponents engaging directly with First Nations in the project area. So proponents really should be engaging as early as possible, including before the tenure application is even considered. And with that engagement, they're sharing information, they're hearing concerns, and incorporating Indigenous knowledge early into the project design. So the idea behind this pre-engagement is really for that relationship to be formed and to provide Indigenous nations with timely and relevant information, hopefully for opportunities as well to participate in the project planning directly and space to raise any of the concerns that they may have before any key milestones are reached. If a proponent decides to move ahead with a project, then they're going to be moving ahead with a tenure application that they submit to the ministry. When that happens, the ministry reviews the application, and if it is ready, moves ahead with distributing out referrals to potentially affected First Nations and local governments. And then with those referral process, we receive feedback, and that is considered when deciding whether to issue the tenure. When and if a tenure is issued, because it's not a guarantee, proponents then complete more direct engagement about the project details. So ideally, this is part of that ongoing relationship that they've formed with the First Nations in the project area. And then when that proponent has enough details about their project to now apply for permits, under regulation, they must follow what's called the notification requirements. And so this is a formal notification that's sent out by the proponent before they can submit their activities application to the BC Energy Regulator. When they have done that, then they can submit their application for the actual activities to the regulator, and the regulator receives this application, reviews it for technical purposes, but then also starts their consultation process at the same time. And through the BC Energy Regulator's consultation process, they're looking for input and feedback that they can consider for part of the decision on that permit. So I'm going to move now into the CCS protocol. Some of you have heard this term before. As part of our CCS regulatory framework includes this concept of a CCS protocol, which is applicable to projects that allow for sequestration of captured carbon dioxide in BC by either injecting and permanently storing the captured carbon in a storage reservoir or chemically transforming that captured carbon into a compound or form that is capable of permanently storing that captured carbon. So accepted projects in BC must meet a criteria that has been established under GRCA, which is the Greenhouse Gas Industrial Reporting and Control Act, and as well as the Greenhouse Gas Emissions Control Regulation and any relevant protocols, in this case, the CCS protocol. So the CCS protocol fits into the broader topic of BC's carbon offset program. So an offset is, probably some of you have already heard today, is a tradable credit that is used to counterbalance or offset, that term there, greenhouse gas emissions. So a BC offset unit represents 1 ton of carbon dioxide equivalent that was either removed from the atmosphere or not released into the atmosphere as a result of direct and beyond business as usual action by the project proponent. These actions are validated and verified by an independent accredited third party to ensure they are real, permanent, and additional. The organizations that have an obligation or a desire to offset their greenhouse gas emissions can purchase a BC offset unit to meet their emission reduction or their net zero targets. Investing in BC offsets helps finance incremental emissions reductions and removals in BC. To have their organization recognized as a BC, to have an organization's activities recognized as a BC offset unit, projects must meet the provincial regulations and requirements outlined in the director-approved offset protocol that I was talking about on the previous slide. Independent validators and verifiers provide the third-party review to ensure the resulting offsets are verifiable and incremental, and the Ministry of Energy Climate Solutions, the ministry I work for, provides that regulatory oversight. So then we get the question a lot as to where's the potential for CCS in the province. The province has in recent years supported several geoscience projects focused on gathering furthering our collective understanding of the potential carbon dioxide storage opportunities here in BC. It's really important that we support this kind of work to really gain that deeper knowledge of where CCS is possible. So mapping and evaluation work has been happening across the province, but really it's identified that the extensive potential for CO2 storage is in Northeast BC. So I believe some of you are familiar with this map, that's up here from a presentation this morning. And the scale and the distribution of the storage potential in Northeast BC is especially encouraging from the research that's been done so far, that it could support multiple CCS projects over many, many decades. So the information listed on the slide with the link there is pointing to the CCS Atlas, or the longer name is the Northeast BC Geological Carbon Capture and Storage Atlas. So that was completed in 2023 by the Geoscience BC, and there is a link to it there. It's quite a large document, so I believe it's downloadable in chapters. And I have for my final slide here, what I hope is going to be a helpful slide for those of you wanting further information. We've linked here further reading about the regulatory framework, and we've categorized it into some of our dedicated ministry websites, specifics about our tenure process, and then specifics about permitting, which would be found at the links that the BC Energy Regulator has there. Let me finish by saying a very warm thank you for all of you again for attending today. And I'd like to open the floor to any questions that folks may have. And hopefully I can respond now. And anything I can't respond to, I'm really happy to follow up on offline later.
You can raise your hand or put a question in the chat, folks, if you like. Okay, well, I think if any questions do arise, I guess Genevieve, you'll be available to answer. Oh, there's one. Byron?
Good morning, everyone. Pleasure to see everyone. I have a question, and this goes, we've been hearing about the carbon credit or sequestering and everything, but how does this all fit in with such things as accumulated, impacts? Because you're talking about overall about sequestering carbon, but there's also the question of cumulative impacts to Aboriginal rights. And how does this actually fit in, or what is the measurable mitigation or measures that are associated with this?
So to clarify, you're referring to cumulative impacts on the landscape, disturbance impacts?
It's no, what I'm asking is, because it's looking at, you're talking about just for one instance, what are you going to do with carbon that is generated from all these various resource activities? But, there's still the overall impact to Aboriginal rights and how to, through cumulative impacts, how does this actually, how do you measure this? And towards those impacts, and how does it go towards mitigating those impacts?
So to the first part, how does it go to the cumulative disturbance and the cumulative impacts on Aboriginal rights? CCS, the way CCS is regulated in the province is integrated into our energy resources activities. So the permits that folks are seeking, operators would be seeking to do a road access or to do any drilling are the same permits and the same processes that they would be having to go through for other activities. So how those other activities are also, cumulatively impacting is the same way that CCS would be. It's considered another type of resource activity. There is a broader question out there right now in this space about how all energy resource activities are affecting First Nations rights and lands. But that's sort of like that part of that broader discussion. And then to your question about how does this fit into like carbon, CO2, greenhouse gas emissions, and the impact that those can have on Aboriginal rights. I think that question is still to be seen as we hope for further project development in this province, specifically of CCS. We should be getting a better idea of how many emissions are able to be captured and stored using this technology. At this time, there are no active projects in the province, so it's a little bit premature for me to say that there's a direct line and that we can see all these benefits. But I believe that is sort of the pathway that CCS is trying to do is to create a benefit for all of us to have lower emissions in the province.
Genevieve, can you hear me?
Yes, I can.
How many abandoned and orphan wells are there in Northeast British Columbia? And what is the budgetary commitment of the BC government to clean up those wells? And the other part of the question, who is doing the cleanup of those wells? Are you accessing any funds from NRCan to do that work? And lastly, when you look at those orphan and abandoned wells, do you do a technical assessment as to their suitability for carbon sequestration storage?
Okay, thank you so much for that question. It's a very good one. Lots of detail in there. So to your first question about the numbers of abandoned and orphan sites in the province, I don't actually have that at my fingertips here. I can get that back to you. We do have official stats on that. The BC Energy Regulator regularly updates those because they run the orphan site reclamation program. So orphan sites are maintained and then closed in, reclaimed through the BC Energy Regulator and the contractors that they hire for that. And there is a cycle for that. They have a very strict policies in place to really get that done in a timely manner. And the amount of money they spend on that is quite substantial per year. The entire program is funded through a levy that is pulled from operators in the area. So oil and gas operators pay a levy that goes into paying for these orphan sites. Other provinces don't have the same system. So if you hear things about Alberta, for example, it's a very, very different system that we have here in British Columbia. Our system was modernized based on some of the risks that we were assessing in the Alberta model. So we don't have quite the same issues with funding as some of the other provinces have had. That said, with regards to funding from the federal government, there was a large sum of money that was put towards orphan and abandoned sites. Thank you, Tyrone. You've put some stats in there. Thank you. Into the chat for those interested. So the federal government came out with some funding that was during COVID. So we created what was called the Dormant Site Reclamation Program, and a lot of money was put forward to clean up sites quicker. So that program has ceased, as you could imagine. It was related to a pocket of money from the federal government for short-term use, but that program was quite successful, and there is information about that as well on the BC Energy Regulator's website. And then I guess your last question was about how they are assessing the wells before they close them in. To my understanding, there is no current assessment as to whether the wells themselves are at a level of integrity to be reused for CCS. That said, it's something that could be considered in the future. The reservoir is usually the first priority to establish the integrity of a reservoir for that storage, and then the wells are looked at secondary. So my understanding is not at the moment. The keenness of folks is to get the abandoned sites, the orphan sites cleaned up, and CCS is happening in areas not necessarily completely overlapping the CCS interests, the exploration and such. Hope that's answered most of your question.
I think there was a budget component to that as well, Genevieve, of what BC spends on this work.
Yeah. So that's something I don't have at my fingertips. It's something we can pull up though and share with Robert. Sorry, was it David, or sorry, who was asking the question? Sorry, I might have noted down the wrong name. It was David. We can follow up with that.
Yeah, okay, thank you. So Byron's got his hand up again as well.
Thank you. This is a bit of a comment, and what it relates to is, when you look at such court cases, in one particular Supply River decision, and what this was made on it was about seismic testing in the north. What the Inuit had said was that. This seismic testing, it's mammals and other creatures in the sea that they're dependent on. And basically, it's seismic testing, meaning sending down the tests would disturb in their and potentially disturb their migratory patterns and others. So, and this is just an example, or just to use that to illustrate this problem, because once you actually start, and what that question was in that particular decision was that, they were expecting an answer through the, from government to actually tell them, well, what are the impacts before you start? And what happened was, and the government said, well, that's what the old Energy Regulatory Board was about, was to provide those answers through the studies. And Inuit said, not good enough, and took them to court and won. And one of the things that they had said was that in that court case was, it's not only, and I'm paraphrasing here, that it's not only imperative that that government determines what the impacts are to the environment, but what are those impacts are to the Aboriginal right. So when you're talking about sequestering and everything, it's more or less, if, a response after the fact, because you're responding to increased carbon due to these developments. But for First Nations, we need those answers prior to, before you actually enter into where it gets to be that, significant enough where that's required, and we're already at that threshold. So my question is, I think that's one of the things that First Nations need to determine is first, before these, resource activities take place, what are the impacts? And in this case, is generation of carbon and others. So, because, that's one of the things that needs to be stated is, Supreme Court decisions right from Sparrow on down had said, while provinces have the ability to infringe upon a that infringement must be justified. And in instances that it also said that provinces do not possess the constitutional authority to extinguish a right. Now you look at the majority of extinctions in this province are actually at basically done in the use of Section 92 powers. We have 6 subpopulations of caribou that are now extinct, and for all intents and purposes, in southeastern British Columbia. You got 13 of the 14 Chinook stocks. So in this instance, I would actually have to ask, when you're going through this, carbon sequestration brings in the question is, again, you're bringing us a solution after the fact. And we need to make that determination what those impacts are before we get to this stage.
Yeah, CCS is interesting in that these projects that we are seeing on the horizon, the type that are coming in, the proponents that are coming into the ministry to tell us about their technology, they're coming in hand with another industrial process. They're not coming in necessarily yet with the direct air capture type units, which would be a standalone system, as standalone as a CCS system could possibly be. Instead, what we're seeing is that they're saying, hey, there's this industrial facility that's already has, its own tenure and permitting process that's going down through various avenues. What if we put a CCS component with that? So what about if we attached a carbon capture component to that industrial process to lower or eliminate the emissions that are coming out of it? And so, yes, I agree with you, Byron, that project, the one that's creating all those emissions, requires consideration as to, where does that fit in with the emissions pathway for the province or strategy of the province. And then for that, is CCS a viable, feasible, and wanted avenue for mitigating those emissions? It could be electrification is a better pathway, or it could be a more efficient system is a better one, or not to go ahead with that project at all.
And Genevieve, are you aware of the Alberta Pathway Project, which is a significant pipeline project to basically deliver on the promise of sequestration?
Mm-hmm.
And is BC considering a similar project?
That's a very good question. So for those of you not familiar with the Pathway Project, in very simple terms, it's capturing CO2 from the oil sands region of northern Alberta there and using a CO2 pipeline to transport that CO2 to areas where they have underground storage ability. It is a very long pipeline that's being proposed in that case. Now, Alberta already has a very large pipeline, a carbon trunk line that was created, built several years ago, took almost a decade to put together though. And that takes CO2 from what they call the heartland, the outside of Edmonton area there, and it brings it all the way down to, I believe it's Clive, Alberta, so central southern Alberta there. So Alberta's history with CO2 pipelines has already been established, and is different from any history we have here in BC, where we do not have any major CO2 pipelines established in the province. So to your question as to whether we are planning any, the answer is no, nothing large like that. But the answer is maybe, in that I have heard that it would be like kind of like the ultimate dream to be able to do something like that, right? To have all the CO2 collected from a whole bunch of different industries in a really heavy industrial area and brought to an ideal CO2 storage place, and that would be a nice solution for that greenhouse gas. Do we have a pathway forward in the province right now for that? No, is an easy, simple answer. There's no talk of building a mega long CO2 pipeline in the province of that type. Could there be like a gathering network or like what could be a large network in Northeast BC where there is CCS being discussed and some exploration going on for storage reservoirs? Possibly. Yep, and that should be part of the conversation up there, where they have active exploration for storage reservoirs. But as far as pipeline opportunities elsewhere in the province, trying to get up to Northeast BC, it's all talk at the moment with no like actual pathway forward.
Or you could examine the possibility of piping into the Alberta system into the future. Now, before you answer or speak to that question, I'd like to as well put another question to you. We're witnessing the unfortunate abandonment of climate change solutions, mitigation policies. We saw the consumer carbon tax bite the dust, and we are witnessing the accelerated permitting for major projects, both in the mining and energy sectors. We're witnessing a walk away from the environmental assessment process. Remember when those wind projects, all 10 of them, got exempted from environmental assessment? Now, are these sequestration proposals, are they going to be subjected to an environmental assessment process in your view? And is BC still committed to a carbon offset program?
So I think your first question was about a pipeline to Alberta. I have not heard any discussion of that at this time. That would be something that we'd obviously need to talk with Alberta about, but also the federal government, because it's actually, because it's a cross-jurisdictional project, it would be the Canadian Energy Regulator that would regulate it. That said, that's the industry that we have in British Columbia, to have it concentrated for collection, like they have that industry at Belt, I was saying, outside of Edmonton there. We don't have near the border with Alberta, right? We have it in Vancouver area, we have it in Prince George area, but we don't really have that same concentration in Northeast BC. There are lots of industry up there, but it's very dispersed. To your question about environmental assessments, so the way environmental assessments occur for a CCS project is based on the project that the capturing is happening at. So if it's happening at a facility that is a reviewable project under the Environmental Assessment Act, then yes, there would be an environmental assessment associated with it. If it's happening at a facility that is not part of the Environmental Assessment Act under the reviewable regs, then the answer is no. However, part of the entire energy development process that the BC Energy Regulator requires for their permitting does take into consideration environmental assessing as part of the impacts for all those permit conditions. So it's how it's split in BC. And sorry, your final question was about the commitment to offsets. So I haven't heard anything otherwise. And I mean, Constantine is on the phone here. He's from our team that works on offsets in the province. But my understanding is that we still have an offset program, the BC offset program, and the offset protocols underneath that program that are sort of like the rules that the companies operators need to follow in order to generate offsets is still ongoing.
Thank you, Genevieve. I think Peter has lost his internet connection, so I'm just going to cover for him briefly for you here. Were there any other questions for Genevieve? All right, seeing none. Thank you so much, Genevieve. Appreciate that. And if anyone has any other questions, we can submit those to you. So thank you for taking the time today. I would now ask to turn it over to Alexander Curry from Natural Resources Canada, if you could go ahead with your presentation at this time.
Hi, actually, it's Chris Taves presenting today.
I'm
Alex's colleague. And I think Alex is going to put up a deck for us to look at. So yeah, I'll be really quick. I realize we're a bit over time, but I'm really happy to be here today, and I'm happy to be invited. Just as a sort of framing comment, I would say the role I'm coming here at. So I'm a director of energy innovation policy at the Office of Energy R&D. So unlike Genevieve, not a regulator, don't have the kind of real concrete on the ground perspective she does, but we lead from the science, innovation. We think about the higher level economic policy issues. And yeah, before I get started, just let me acknowledge that I'm calling in today from Ottawa, the unceded territory of the Anishinaabe Algonquin people. So hopping right into it, carbon management, we've kind of spent a lot of time talking about CCUS, at least in the time I've been listening. But just as a sort of refresher, like we really think about it as CCUS, the direct capture from industrial facilities, plants, and so on. And also the more emerging part of carbon management being carbon dioxide removal, pulling carbon dioxide right from the atmosphere, and lots of emerging techniques such as bioenergy, mineralization, marine-based, many of these being very early stage and quite frankly, at a real sort of scientific discovery phase. The department's biggest piece for looking at the carbon management sector is the carbon management strategy. Canada released this in 2023 after engaging nearly 1,500 stakeholders, including Indigenous partners, industry researchers, and civil society. It really puts forward Canada's vision for growing a competitive multi-billion-dollar sector, contributing both to climate and economic objectives. In brief, it outlines a roadmap to 2050. It identifies 5 low-carbon pathways, identifies a number of priority areas, and our focus now is sort of implementation and moving the sector forward, and where progress is underway. The key takeaway from the strategy I want to leave you with is that these technologies are usually most relevant for the sectors that are difficult to decarbonize in other ways. So thinking of cement, thinking of mining activities, industrial processes. And yeah, as I said, the overarching goal really is climate and economic potential here. You may have noticed the new government is now talking about this in terms of climate competitiveness, trying to bring the two opportunities together. So, from a broad national perspective, what is Canada doing in the space? So, we've been a global leader for decades. We have lots of natural advantages. We have the right kind of geology for storing CO2. We now have a depth of expertise in industry. We have a strong research innovation ecosystem. Right now, we're home to 9 of the 77 commercial scale CCUS projects around the world. We rank 3rd in the number of projects in development globally. And there's an estimated 84 carbon dioxide removal firms operating across 8 provinces. In terms of the suite of policy and program measures at the federal level, we always kind of refer to this pyramid, which is from, I believe, from an old budget. Starting from the bottom. Of course, the foundation is the rising price on industrial carbon and regulation. So the industrial pricing system has stayed, while the consumer pricing system, this government has removed, as you know. So this is really the foundation, creating financial incentives and investment certainty. Canada also offers a suite of investment tax credits to help costs of projects. They provide refundable tax credits to companies for eligible expenditures. BC, for example, is an eligible jurisdiction under the system. Canada also supports the financing of commercial projects and infrastructure through the Canada Growth Fund and the Canada Infrastructure Bank. And finally, we have real targeted programs to support carbon capture and storage. One of them, which runs out of my division, the Office of Energy R&D, a $319 million program to support CCUS research, development, demonstration, and to advance CCUS projects from a late stage to final decision. What are some to be a little, maybe a little more targeted to you here today? So what are some of the opportunities for First Nations and carbon management projects? So the carbon management strategy, first of all, directly reaffirms Canada's commitment to working with First Nations and Indigenous peoples to support their participation, ownership, and decision-making in sustainable natural resource development and deployment of clean tech. More concretely, for example, the CCUS program I was just talking about is open to Indigenous organizations, among others. It could provide between $3 to $7 million in funding, covering up to 50% of eligible project costs, or up to 75% for Indigenous applicants over a maximum of 5 years. It also allows Indigenous applicants to stack government support of up to 100% of project costs. So in recognition of some of the unique, unique aspects that Indigenous applicants face, the support's a little more generous. NRCan, outside of my division, as you probably know, NRCan's been working on the National Benefits Sharing Framework. I actually did work on that in a previous post in the department, and I'm really happy to see it coming forward. Along with the Indigenous Loan Guarantee Program announced in 2024, which provides guarantees, as you know, to support acquisition, equity stakes in commercially viable projects. This, of course, can include carbon management. Overall, I think like the economic opportunity I speak of in the space, of course, through the benefit sharing framework, also creates economic opportunity for Indigenous communities. and Indigenous businesses. Moving on, I can make a few more quick remarks just about what my division does, the Office of Energy R&D. We're the federal lead for programming and funding for energy research, development, and demonstration. So CCUS, carbon management, is just one of the many energy technologies that we work with. We do things such as batteries, electricity technologies, clean fuels, AI. So we cover quite a wide gamut of energy innovation. Fundamentally, we invest in R&D to support technologies to reduce emissions. And we have a much broader track record than what I was just talking about in the carbon management space. We have a much broader track record of engaging with industry, Indigenous partners, and the public. For example, in BC, we have a partnership with the BC Innovative Clean Energy Fund and the BC Industry Fund. We also have a number of federal labs advancing science. We play a lead role in developing policy frameworks, such as the Carbon Management Framework. And we represent Canada in various international science initiatives. Some examples of what we worked on in British Columbia. This slide just shows a few companies that have received federal funding through NRCan programs. It showcases really that our funding supports many stages of project development, from early research to small-scale testing to planning, really with the overall goal of bringing things to market and leading to commercial technologies. And finally, to close off, just a few recent developments. We recently announced $60 million in carbon management R&D funding through our flagship Energy Innovation Program, supporting 21 projects across the CCUS sector. We have an active call right now for CCUS front-end engineering design studies. And yeah, just to close, I would encourage you to stay connected with us. I'm happy to answer any of your questions, recognizing I'm sort of have a science and innovation remit, and I'm really glad to have been invited, and appreciate you listening.
Yeah, thank you, Christopher. I'm sorry my internet dropped off there for about 15, 20 minutes. So I missed a bit of this, but thank you very much for that. And I wonder if there's any questions.
I'll start the questioning period. Christopher, as we all witnessed, Carney and Smith signed off on an MOU. Our leadership was never invited nor consulted with respect to the negotiation and sign off with that MOU. And as well, neither was the province of British Columbia. Now, the purpose of the MOU supposedly was to facilitate major resource development, including a pipeline from Alberta to the West Coast. Now, it also talks about a requirement for Alberta and industry to commit to the Pathways Project, which would facilitate the sequestration of carbon. Now, from your perspective and your understanding, is it a requirement that the Pathways Project precede any potential oil pipeline to the West Coast. There's, I think, a lot of ambiguity and questions about that. There seems to be a linkage of those two projects, and one would expect that the building of the Pathways project would precede a potential construction of an oil pipeline. Can you share your thoughts on that question?
Yeah, like I can share a few general thoughts. I wasn't at all in the tent on what's in the PM's mind there, what that's supposed to mean. Like we did observe it from where we sit. Like I could, just sort of speculating, both the Pathways project and any potential new pipeline are very, very long-term complex projects. The pipeline, I don't need to tell you, of course, there will be like rigorous Indigenous consultations and lots of questions on whether those communities would in fact consent to whatever pipeline route would happen. So very complex and uncertain if the pipeline would happen. I think it would be fair to characterize the Pathways project in a similar vein. It's complex. It's involving a big sort of coalition of companies with different interests. It's a very, very costly project. It remains to be seen if the oil companies are willing to foot the bill to build it. So yeah, both are complex, both are uncertain, and if I had to guess, I wouldn't say no, it's not a case of one preceding the other. I would also note that, which we like to see, that the MOU contained some conditions on Alberta to increase their industrial carbon pricing, to sort of up their game in holding industry to task, in reducing emissions and being a little more competitive.
No, yeah, thank you for that answer. I mean, it's still ambiguous. There's still
it's very ambiguous.
Clarity as to which precedes the chicken or the egg. Now, turning to LNG Canada, your government has signed off on phase one of the $40 billion project in Kitimat. And as I understand it, phase two is now under consideration for approval, pending a final investment decision by the consortium, the members of that consortium. Now, we all know there's seemingly an attempt to cast natural gas as a clean fuel. We all know that to be untrue, that the burning of natural gas does emit carbon gases. And right now, I think we have a system there of the current operation where a lot of that gas is being flared into the atmosphere. Now, are you aware of any airshed analysis as to the level of carbon emissions that the entire project, if brought into operation, would emit to the atmosphere in that area? And do you have any monitoring of the current level of emissions that are being generated by the operation of phase one?
Not really my area within the department. Happy to follow up and put you in touch with the sector who would be advancing that major project and have an idea of what I can share, like in terms of carbon capture and storage. We look at both capture capture from, say, oil combustion and capture from LNG combustion. Carbon capture for LNG seems to be an increasingly popular idea, though it is less efficient, meaning that LNG, while no, not like emission-free energy, it does burn cleaner than oil or coal, and so capturing the gases in carbon capture becomes more complicated, more expensive, more energy intensive, and so on. But yeah, if you wanted to talk to people about the LNG Canada project and the department's involvement in it, I'm happy to arrange that for you.
But would you not agree, at this point, there is no initiative to capture the carbon that is being emitted at present, nor is there any conditions that we've seen that it would be required for the entirety of the project, including phase 2.
Sorry, I don't have knowledge of that project. Not something that I work on. Again, my remit is more on science, innovation.
While carbon emissions into the atmosphere is a question of science.
Yes, but I don't know the specifics of that project and what it's emitting and what the plans are to capture it. Again, like we do think, we do think of carbon management technologies as being able to capture emissions from LNG combustion. Yes, like that is a thing we work on, and it is a thing that's popular now.
All right, Christopher, final question.
Okay.
Should phase 2 be brought to fruition, will the residents of Kitimat have to wear gas masks and able to live up there?
I should hope not.
Well, you won't find me fishing there.
Thank you, Dave, and thank you, Chris. Have Tyrone McNeil made a comment in the comment section, so please go ahead, Tyrone, and Byron, you'll be next.
Thanks, just turning on my camera if it works. Yep. There's some aspects of the decade, framework-wise, you're going down the right path, but it's got to be grounded a little bit more in BC here in terms of BC's realities and what's available for sequestration, for storage and whatnot. So it'll be interesting to see that deck retooled for a BC context, but specifically moving away from Indigenous to First Nations. It's a misnomer the way tourist Indigenous folks are claiming rights and title in here in BC. The intent and nature of what it is you're doing and shaping in that PowerPoint, I would relate back to your reference to the Canada Energy Regulator and its Energy Futures Initiative. It does play a role nationally on some of the carbon reduction, GHG reduction and whatnot. Comes directly in play when it comes to interprovincial power lines and oil lines and offshore energies is within its mandate. What's kind of missing there in the energy futures piece is emphasis on carbon reduction, GHG reduction. That is relevant and meaningful. It's kind of crazy putting together a national GHG reduction plan that's irrelevant to First Nations living in a remote community. We either turn on the diesel energy or diesel generator, or they had no electricity, right? So a bit of a reality check from our worldview, but a big piece of that goes to our capacity and capability to even respond to and feed into these and those kinds of initiatives from a community lens, from a lived reality lens, from a First Nations rights lens, and actually input meaningfully back into it. the CER's work on energy features was set aside. We should have redid it, and I'm not here in this capacity, Christopher, but just signal to you, I am the chair of the advisory to the Canada Energy Regulator. So I've got to work in relation to the board and senior management, so in pretty deep with the CER. We're supposed to update the energy futures in 2025, but due to the shenanigans happening south of us, against my arguments, the board decided to bump it for later consideration. But it goes back to, and now this is the comment I really want to make, Christopher, and everybody else here. There does need to be focus in key areas like this, but it has to be done in a planned, a strategic way, right across the board, and all things that are reflecting, in some cases even respecting GHG, carbon dioxide, whether it be reduction, sequestration, capture, mineralization, whatever opportunities is, right? So a master game plan. I'm not actually active in this field enough to be aware of that, Chris. But I can see from my position at the CER, there's a disjointedness here, and I wouldn't be surprised if there's disjointedness in other aspects as well. And then the last comment for now, how these kinds of initiatives fit into British Columbia, Canada, and the UN Social Development Goals. And I don't see references there often enough in this. There's either BC or Canada are doing, and you'll hear a little bit more about that from my presentation after this. I hope all that made sense. Thanks.
Yeah, thanks for your comments. I mean, the one thing I'll pick up on is, as you know, there's likely another energy futures in the pipe. We have been involved in helping shape a little bit through a different part of the department. But what you said about it, like starting to account for carbon dioxide removal, struck me, because for the first time, the IEA, the International Energy Agency, is starting to really do this on a global stage, and they've basically indicated that we're at the point where carbon dioxide, having to administer carbon dioxide removals is now mandatory. There's no scenario in which we're just going to reduce emissions and return to some sort of normal climate. So it's, I've spent a lot of time talking about CCUS, but carbon dioxide removal and the various techniques is definitely a very up and coming, very rapidly development sector that eats up a lot of my time these days.
Right, thank you, Chris. Byron, please go ahead.
Yeah, thanks. I got a question, because you mentioned this whole issue about national benefit sharing framework. And, and I quickly Googled that, and it says that this framework is a part of Canada's commitment to economic reconciliation and aligns with the United Nations Declaration on the Rights of Indigenous Peoples, or UNDRIP. And my question to you is, how is this all going to be measured? When you're looking at reconciliation, you're basically talking also about impacts. And when you look at it, Canada has probably one of the worst means of measuring any type of socioeconomic interest for Aboriginal peoples. And it's based squarely on the fact that government does not like going to court and not having the benefit of the courts deciding any type of injunction against First Nations based upon a cost-benefit analysis, or not cost-benefit analysis, or the balance of convenience. And what this means is, if there's any impacts to industry, communities, any other user groups, this is clearly defined when that is going forward. Yet when First Nations go in there, the rights and the benefits or of the values, sort of there's the qualification and quantification of a right is not even adequately developed in Canada. And it comes out to this: so Chief, where did you pick berries? And what kind of measurement is that? So my question to you is, when they're talking about the National Benefits Sharing Framework, and it says that NRCan is actually heading this up, what is their socioeconomic analysis model that measures the impacts that they are basically going to be reconciling on, and what's the process that's going to be undertaken to achieve that? That's my question.
In short, I don't think NRCan is the department that thinks about that. Like NRCan is the department that thinks about the natural resource sectors, its constitutional obligations to Indigenous groups, its constitutional obligations to free, prior, informed consent in Section 35 and all that. I think, you know, the Indigenous departments in the federal government are the ones thinking about the social quantification of reconciliation. But yeah, like we're thinking of concretely how can benefits be shared in terms of equity, in terms of jobs, in terms of contracts for Indigenous communities. We also have what is it called? The Indigenous, oh, it slipped my name. We have a sort of a capacity building program that helps Indigenous communities basically work with proponents. So if an Indigenous entrepreneur comes in and needs such and such equipment or such and such expertise to secure a contract from a natural resource proponent, we support that. So like we are pretty squarely focused on kind of the economic side and trying to make our stakeholders, the natural resource sector proponents, live up to their obligations and be sort of good exemplars of what it means to share benefits and to work towards reconciliation.
I think that's one of the questions I really got to ask. You mentioned concrete in there, and again, this goes right back into reconciliation. And if you look at how NRCAN's project, and they talked about in that slideshow, $15 billion program. Well, even in federal procurement, that is for 5% for Aboriginal peoples. You're talking about 750 billion. Million. And but again, when you're looking at reconciliation and being able to look at how are you going to reconcile, there needs to be some form of measurement of what is required for that type of reconciliation to happen, especially on any type of development that directly affects our ability for accessing food, as per instance salmon. And a lot of people around this have heard me say, just in one of the nations with 10 million people, if you look on them consuming 1,000 pounds of fish per year, you times that by 10,000, that's 110 million. Then you times that again by 1250, you're talking about 125 million for loss of food fish for a community of 10 million people or 10,000 people. So, you'd have to forgive me for basically me asking this question because it's so important. And again, there needs to be a means of measurement to mitigate or to reconcile those infringements, because what you are talking about is the requirement of the government to justify their infringements. And if you're talking about infringements of that magnitude, you need to be able to justify them to basically shape the reconciliation or the measures to meet those impacts somehow, some way. And it's not good enough to say, well, this belongs to another federal department, so this is what we're handling. You are all infringing upon our Aboriginal rights. And I think there needs to be some sort of requirement of how it's going to be mitigated, because how can you even talk about reconciliation?
Yeah, look, I totally appreciate your perspective. I do recognize that reconciliation is is really the work of the whole government. Like I can share that in one of my previous roles at the department, having worked on say regulatory approvals of various natural gas pipelines and stuff, we worked quite exhaustively with the implicated communities. The department has a whole division called Nokwewash, which is kind of our lead for Indigenous affairs and Indigenous engagement. So where there are federal projects and where there is a federal role in in working with communities to understand impacts, to understand cumulative impacts, to ensure that free, prior, and informed consent is obtained, to ensure that like appropriate mitigations are put forward. That's taken, like, I want to show you that that's taken very seriously. It's very rigorous. Basically, I think since the TMX pipeline, like the legal, as you probably know, the legal system has raised the bar quite a bit on what's required, and that's a very, that's a very positive development. But yeah, like, not to dodge again, like I will say a vast majority of natural resource projects fall under provincial jurisdiction, so such as Geneviève, and there the province leads on the specifics of which communities are implicated and how impacts will be redressed. But yeah, like closing up, I agree. It's a whole of government responsibility, and it's important we're all thinking about it.
Yeah. I just want to make one final comment, then I'm going to shut up. I think that's one of the things that the federal government needs to realize is under the terms of union for British Columbia in 1871, that British Columbia as a colony demanded before the Joint Confederation that the Dominion of Canada would take the responsibility of Indians, lands reserved for Indians, and a trusteeship. And the only thing the province actually held was at a request for lands to be set aside for use and benefit of Indians. That was the only time that they wanted to be involved in this. So we are talking to the right authority, and we need to be able to have those answers. But I'd really like to end that is, could I have a link to that website you just mentioned that's actually developing that? What do you call it? NAQUAP or whatever it was.
Oh, no, Quawash. It's not a website. It's a part of the department. Like, I'm happy to put you in touch with people there to discuss the work that they're doing.
Yeah, I'd like to see, if there's anywhere it's published, I'd sure like to read it.
Sure. I can get you in touch with that.
Yeah. All right. Thank you.
Thank you.
Thank you very much for your questions, Byron. Appreciate them. Christopher, is there a way for you to put that website or a way for people to reach that portion of your department?
Yeah, who can I follow up with after the call? Will that be you?
Probably Mark Blom. He's on here. Mark?
Sure. Thanks, Peter. And Chris, yeah, FNEMC is aware of Noquewash, and we can help Byron find that information that he's seeking.
Fantastic.
Okay, thanks very much. I'm looking through the attendees here, and I don't see anybody with their hand up. Any more questions from anybody? Okay, hearing none. Christopher, thank you very much for your time. I appreciate the challenge of what your authority is and some of the questions you're being asked, and certainly hope you convey to the folks who are responsible what some of the questions were, and we continue to work forward together on these matters. So
yes, thanks for having me, and I love the discussion, like complex national issues here. So yeah, I appreciate it.
So thank you again. And next up on the agenda, we have a First Nations perspective on carbon sequestration and storage with Tribal Chief Tyrone McNeil. Tyrone is a Stolo member of the Seabird First Nation. He's got extensive experience working to advance First Nations languages and education, collaborating with First Nations across the country, and developing agreements and partnerships with government. He's a chair of the Emergency Planning Secretariat in the Lower Mainland. He's also manages a First Nation construction company that employs up to 70 people. He's got experience. The company has experience in operational health and safety, audits, human resource management, operations, budgeting, and civil construction and pipeline industry. And he also holds numerous leadership positions. He's one of those guys where you wonder when he ever sleeps. So just a few of them: president of the Stolo Tribal Council, special advisor to the First Nations Leadership Council on Emergency Management, chair to the Indigenous Advisory and Monitoring Committee to the Canada Energy Regulator, and standing chair of the Union of BC Indian Chiefs, among many other things. So, Tyrone, please go ahead.
Thanks, Peter. That bio is a little bit dated. I'm not chair of the union anymore, but spent 13 years there. But thanks for having me, everyone. I really appreciate Mark reaching out to me to share some of my thoughts around this. I do what I can to support Dave and the FNEMC and the good work that you're doing. So I really appreciate some opportunity to share some of my thoughts around carbon capture, utilization, and storage from, I'd say, from a Stalo perspective, not a broad First Nations perspective. And if you heard me earlier, certainly not an Indigenous perspective. And building on my comments to Christopher about pieces of the puzzle, I think carbon capture, utilization, and storage is a component of it, and absolutely agreeing with Christopher's statement that we can't use any natural mechanism to catch up on carbon anymore. There's got to be technology brought to bear to actually capture carbon dioxide, and appreciating that the carbon dioxide is a component of the GHGs. There's others that actually do more harm. They might be less emitted into the atmosphere, but do more harm, like methane. And when you're talking about I think Dave raised the question, how do you measure those kinds of emissions? That I am aware of. There's satellite tracking that'll tell in detail the amount of emissions being distributed in real time by a factory or by a component of construction in linear projects like pipelines or transmission lines. In my comment earlier around the ability to have conversations, it's, many of us struggle here. This is new space, but we have to build capacity on it, right? Otherwise, government and provincial government and potentially even industry would do things that don't recognize who we are as First Nations, our rights or respect, or build those rights into what it is they're doing with response to carbon and reducing carbon. But being mindful as chair of the Emergency Planning Secretariat, we initially put together a common emergency management strategy for the 31 mainland coast Salish communities from Yale to Semio to Squamish. But it didn't take long for that to morph into a climate resilience plan at the same time, because you can't just respond to emergencies. You have to do what you can environmentally and climate-wise to reduce the severity and frequency of serious disasters going forward. And I'm structured in such a way that it's chaptered, and we've got about 14 chapters described right now, and about chapter 20 is going to speak to carbon reduction throughout our homeland, Fraser Valley, Lower Mainland, in such a way that the local authorities responding and doing things differently, more in line with our priorities and our rights. For example, I've got in there, every public building over 10,000 square feet has to have, by regulation, we're required to have a green roof. And when you think about green roofs, what's the point of throwing grass or weeds up there? Let's throw dwarf fruit trees and berries and whatnot, so you can actually produce food off of it to add value to that, the greening of the roofs and whatnot. There's got to be permeable sidewalks and roadways that allow the surface water to drain into the soil and ultimately, hopefully, into the aquifer. So the idea of carbon and doing things with carbon has been on my mind for a while. I was happy to work with the mining council to try to build some capacity within communities around energy consumption. And although that's the way the first one was aimed, my interest was, once we build that capacity, I'd really like to see all First Nations in BC have a GHG reduction plan or a net zero plan, carbon reduction plan, something like that, right? And being absolutely fully cognizant that if and when we get to a point of net zero between now and 2100, somewhere in between, well, however bad our climate is, net zero is only going to sustain that same climate. So the severity and frequency is going to continue getting worse year over year until to a point that that's our new norm, right? So in some cases, and I would argue that First Nations in particular play a big role in doing better than net zero, and doing that in an effective and efficient way that recognizes we do play and potentially play a significant role here. The current scenario of the government's response to electrify as the best response to um, being most responsive to climate adaptation, climate response. My worry there is BC Hydro's infrastructure. On one hand, I hear from folks that know way better than me that if BC maxed out its internet server capacity, BC Hydro doesn't have enough energy, period. And now you add a need for AI capacity as well. So the current ability of BC Hydro to generate real needs here and in a very short while, tomorrow and the day after, is should, at a minimum, questionable. And then directly related to that is the BC Hydro's ability to move that electricity throughout the province. The transmission lines are getting more and more dated, appreciating that there's commitments to make some significant renovations of this transmission system, but yet to see it in a meaningful way. And the opportunity for us to look at the landscape, whether you call it carbon GHG reduction, carbon sequestration, recognizing that we do have rights first and foremost. Certainly, the Declaration is going to play a big piece of that. But you go to constitutional rights, you go to case law. Chilcote in 2014 recognizes we have title over our traditional territories, and with that, there's an economic benefit to it as well. That when Yahi came along, it put cumulative impacts on the table. So when we're talking about the sequestration or storage or repurposing, reusing carbon, we got to look at it from a multi-generational perspective, and you can take that into consideration in terms of what it is that we're doing, and particularly putting the precautionary principle on the table in that as well. So whether you call it holistic or broad or race-based, I really look at all of those as my and our worldview of things happening around us. One of the tools I've been bringing to bear around a lot of the hats that I wear is the UNESCO's Social Development Goals. So if you take a look at the report that the Energy Mining Council did, it's fully in line with goal number 7 around affordable and clean energy, goal 9 around industry innovation and infrastructure, 13 around climate action, 15 around life on the land, 17 partnership partnership goals for First Nations industry and government collaborations. And we're still trying to find our way there. Although we have the DRIPA in place here, by the sounds of it, EB is going to kowtow to the racists that are out there and try watering it down. But my leadership that taught me, been in it 30, 40, 50 years more than I have, tell me that and remind me that the United Nations Declaration of Rights of Indigenous People, it doesn't give us any more rights than was already in Section 35. The challenge here is that we're moving down that path, the federal government, but the provincial government, for various reasons, doesn't recognize our rights the way they're supposed to. Byron spoke to some of those early considerations around the terms of union. The British North America Act plays a role, Royal Proclamation. Gee whiz, I get frustrated here, gang, because I remind some of our leadership sometimes that in Calder in 1973, the Supreme Court recognized that our right to self-determination, self-governance continues. But we have such limited opportunity to express that on our reserves, let alone on a broader landscape. And really, it's our broader landscape that we're talking about here. The ability to have officials, initiatives, programs, ideas recognize and respect our rights and a larger geographical footprint is really important. We have all kinds of tools, a declaration, case law, and the SDGs that'll support us there. But a big piece of that is the lack of cultural competency by folks, by systems, by programs, by initiatives. And some of the work I'm doing, I'm transitioning from cultural competency into cultural integrity and then ultimately cultural intelligence. And I think we need a systemic approach here geared towards carbon, GHG, those kind of things, because in order for us to have a meaningful impact on our ability to reduce carbon and GHGs and community level, we've got to build capacity to do that. The need for DRIPA's call for alignment of laws. Consultation is a big one there. The trigger for deep consultation, the trigger for accommodation, in particular by either order of government. Right now, there's an over-reliance on industry doing a lot of that compensation to us and for us, but it's inadequate because the Crown is actually impacting, infringing on our rights too, and they have to step in a different way. When initiatives like a broader land base look at our lands, quite often they look at it as a piece of real estate. And when Byron's talking indirectly about a regulatory impact assessment statement or a socioeconomic impact analysis, there's got to be a different lens put there through our worldview. Well, when you cut down a tree, it's not just cutting down a tree. It has a different value to us. When you punch a road in, when you're doing carbon storage potentially on our homelands, it affects our rights indirectly sometimes. Well, we need to run some models on what does that look like in terms of impact and what is the result of it, and use those not only to recognize and respect their rights, but to lever it into meaningful economic partnerships. And it's beyond equity. There's no reason we're not leading this. We're owners of these kind of things and using other folks to bankroll us to get there, because there is going to be a really significant carbon economy going forward. And right now, we're not a part of it the way I feel we should be. And even looking at my homelands, from Yale to Semiahmoo to Squamish, about 26,000 square kilometers. And in that, I figured there's probably about 250 hectares of wetlands that qualify as teal carbon, that have a carbon value to it that right now isn't generating anything for anybody. The naturalization of carbon in our forests, in our backyards, it needs to be quantified. And for those of you that have the good fortune of having old growth forests in your homelands, good for you, but let's add those to the list and secure their safety as well. The recognition that when you're talking about sequestration, whether it be teal carbon, blue carbon, natural carbon, carbon storage, none of that can be done outside of our tidal lands, regardless if you Stalo, Inselkapnel, Schweppen, and so forth, right? So that recognition has to be there. And quite often when we're seeing the economic benefit for those kind of things, too often what folks are doing in oil seems to be the standard. And just given the nature of what carbon capture, carbon sequestration does in terms of reducing the liability of that oil sector, I would argue it needs to bump up significantly the revenue share, the royalty, the tax in lieu, whatever it is that you call it, and that be factored into the economic scenario as well. We need abilities in when we're putting together that carbon strategy, that we're setting the stage for First Nations participation, collaboration, oversight in those activities. Something as simple as permitting. We look at allowing permitting and permitting provisions different than existing regulators do. Too often we're pushed into a position of monitoring such projects when I would argue monitoring plays a big role, because we need to be seeing the effects firsthand on the ground, but we also need an authoritative oversight standard put in place across the board as well, because right now although the Canada Energy Regulators updating the onshore pipeline regulation is still not going to fully meet our needs. So on a project basis, we need more oversight and more authority on key decision-making areas, particularly as it pertains to key features of the land. In carbon storage, what do the long-term liability frameworks look like? What is the potential for insurance strategies around there? A lot of the national and global insurers are looking at long-term effects of carbon storage, and how do you reduce liability around that for the proponent, and I would argue more importantly for the environment around them, because we certainly don't need a large release of stored carbon anywhere in our territories. So appreciating a lot of the discussions going to be in Northeast and BC outside of my area here, but and in that recognizing seismic activity certainly plays a role, which adds to the liability risk, particularly in the Northeast, although typically they're in a seismically safe zone. With all the fracking that's taking place, they've actually had some significant quakes up there as a result of fracking. So what is the ability to store carbon as some of that fracking damaged subterranean areas to limit earthquakes going in the future. That'd be an interesting one to look at. The ability to take a rights-based path forward around emissions reduction, clean energy, including co-production, our economic participation, and long-term stewardship and oversight across sector of CCUS. I think we need to package that up. As you heard me say earlier, we need to look at try to define the big picture to know what it is that we're doing sectorally in each area. And appreciating when we do that is, some of it's going to be our best guess, best scenario, using the tools of the day that are going to change soon in the coming years, particularly around artificial intelligence. I think that's going to play a significant role here, not only in us designing First Nations participation in all things CCUS, but the ability to run modeling around the potential impacts, effects, particularly around the capturing of carbon. And I think we really need to pay attention to that. Where are the best localities to invest in infrastructure to capture carbon? And what do we do with it? What are the opportunities to do with it? And on our larger geographical footprint, like my 26,000 square kilometers in my backyard, start designating land use plans for no-go to development, limited development, and development opportunities. We can get a better idea, strategizing what is the carbon sequestration value of key areas of our landscape in a layered model, from fully naturalization to fully forested and natural forest to take advantage of the natural carbon sequestration. What are the teal carbon values on the coast? What are the blue carbon values? To start generating an economy out of it that we put back into it. I know, and I'll end this way, when I've got resources available, just by our worldview, by the way we are, it's going to be put back into greening my surroundings around us, rebuilding fish habitat, encouraging biodiversity, those kind of things. And I put that on the table because those kinds of considerations have to be put on the table early to reduce our emissions, to put us in a place that at some point in the future, we're not having to capture as much carbon. We're not having the effects on the climate like we are currently that are rising exponentially. I hope that makes sense, Peter. I'll end it there, I think.
Yeah, sure. That does. That's a powerful presentation, Tyrone. I really appreciate your comments. Does anybody have any comments or questions for Tyrone? Just scroll through the list and nobody has their hand up.
But I have a comment. Tyrone, thank you very much for that in-depth presentation that you've made. And I'd like to express my appreciation for your leadership in the resource sector. There are very few leaders in the province that have the depth of knowledge in the resource sector that you possess. And so we're always thankful when you step up and join the conversation, and in many cases, lead the conversation. Now, we are in a very difficult spot in the resource sector. We've got legislated, fast-tracked approval process not only being thought of and proposed, but we are witnessing their implementation. And we're also seeing a major abandonment of the regulatory sector on significant policy areas that were designed to protect the environment, our people, and the health of our communities and our environment. And I don't see that process abating or stopping anytime soon. As a matter of fact, I see an acceleration of basically legislated permitting and approvals of projects going forward. Earlier, I pointed out to the wind projects that were the result of the first call to power from BC Hydro. 10 wind projects were exempted from the application of the Environmental Assessment Act, and we can anticipate that that is going to become the norm as to the exception moving forward. And in addition to accelerated permitting, we're seeing an abandonment of climate change initiatives, policies, and regulations. The Western governments are walking away from any commitment to the fight to push back on climate change and to mitigate the impacts that we're experiencing now, which we all know will only accelerate going into the future. It's not a very optimistic picture that we see, but I think that that's got to invigorate our leaders to stand up and to push back hard. As some of you may or may not know, I'm coming to the end of my tenure as the CEO of the BC First Nations Energy and Mining Council. And although that is, in some cases, a sad event, but it also is an invigorating, free release in some way. I can now say anything I want to say without fear of reprisals or rebuke from the political class. And I think that we've got to encourage our leadership to invest more of their energy on resource issues. My experience is that the dire circumstance of our socioeconomic conditions in our communities, we get pulled away, and our large part of our focus is on social issues. They need to be there, no question about it. But I think that we need to pivot and that we need to shore up the front line with respect to protecting the land, the integrity of the land base, and as well become more engaged on the discussion of the extraction of our resources and the shipment of our resources out of our territories to markets elsewhere, and that we only get left with the impact of that process and not the benefit. That is a situation that has to be turned around, and we really need to redouble our efforts to protect the Aboriginal treaty rights, our Aboriginal title, and the existing and modern treaties that have been negotiated, and the situation calls for more action, and we're witnessing the specter of a provincial leader who made his career supporting human rights, now on the cusp of eviscerating one of the most important documents to ever emerge that recognizes our human and legal rights. And that, of course, I'm speaking to the United Nations Declaration on the Rights of Indigenous Peoples. The current government is caving in to the call for abandonment of the UN Declaration. And the governments, whatever stripe they are, they've always said, you know, we're a country of respect and adherence to the rule of law. Well, we're seeing here a clear demonstration that the only time that they in fact respect the law is when it serves their interests. We've been batting 1,000 over the last decade or so on major legal cases in this province and elsewhere in the country. And when they win a court case, which is a rarity these days, they immediately enact the results and implement the decision. But conversely, when we win, and we've won many cases, they take the course of putting the brakes on. They go and appeal. The Gitgatla decision, a really important decision that questions the constitutionality of giving our resources away through what we call the free entry process. And they've refused to step up to the plate in renegotiating the Mineral Tenure Act, which is a legal instrument that gives anyone from anywhere, any country, the ability to go in and lay legal claim to the mineral resources in our territories. And we, this is a significant juncture in our relationship with public governments in Canada and specifically the provincial government here in BC. And I think that we've got to dedicate ourselves to strategies that can reverse the flow of denialism. And obviously, I've, in a discussion that we were invited to by the Leadership Council a month or so ago, on ideas as what are some of the things that we can do to push back on the current government. And one of the suggestions that I made was that there has to be a summit, there has to be a sit down of our leadership and the premier. And the other two people that should be invited to that discussion are the two elected First Nations members of the NDP caucus. I think we're at that critical juncture, and that meeting then I think would have the potential to do a significant course correction as to where we're headed. If that's not the case, and if the government ignores the representation of our leadership and proceeds to eviscerate the UN Declaration Act and reduce it to an aspirational document, then I think that there has to be, in my view, a demonstration like we've not seen before in the history of the province on the lawns of the legislature in Victoria. There has to be a clear message sent. And the other thing is, in addition to continuation of a legal strategy, and I think one of which we need to move toward is to bring legal action for the alienation of our lands. and compensation. When they do register a mineral claim, when they give out a permit for any resource development, that's gone. And that there is no process that can undo that decision, and then others then benefit from the extraction and development and sale of our resources. And so I think that it would be a good idea for our leadership to look at a legal strategy where, whether it be a class action or a number of individual legal actions, that put the question of compensation for the alienation of our lands and our resources. And the last thing I would like to suggest that our leadership look at, if the provincial government is going to vacate the recognition and application and implementation of the UN Declaration Act, why don't our leaders consider issuing legal orders of their own to adapt and to adopt and entirely all of the contents of the UN Declaration? And the message would be, if you, the provincial government, take the position that you have no jurisdiction to recognize UNDRIP, we, the First Nations, have the jurisdiction and the ability to exercise our laws. And one of our laws is that the UN Declaration in its entirety is legally recognized and upheld and will be implemented by our governments, so that if public governments or industry want to engage with us, they would have to engage on the basis of the content of the UN Declaration. So forgive me for going offside and taking the conversation into the political realm, but this is probably one of my last opportunities to give voice to my concerns and my thoughts in regard to the time and place that we find ourselves. And so, in conclusion of my remarks, I would like to thank all of you that have joined the conversation today. This has been one of the key areas of the First Nations Energy and Mining Council is education and literacy on resource issues. One of our responsibilities is to act as an advocate, and we've done a number of papers on resource issues and a number of webinars, and we have more to come. The organization will continue on this path, and I thank each of our members of our community throughout the province for stepping up and participating in this conversation, as we all appreciate these conversations are necessary to gain the knowledge that we require to make decisions on behalf of our nations and our communities. And in closing, I would like to thank the presenters for today's webinars and appreciate their commitment to a sharing of information. And and we always have to remember that for the most part, people who dedicate themselves to public service are good people. Many of the rank and file of the bureaucracies of public governments, in my experience, are there for a reason, that they want to help build a better society for the most part. And so I recognize those partners that have participated over the years from public governments and industry. And for the purpose of this event today, I'd like to thank the staff of FNEMC for this their effort to organize this event. And Peter, I'd like to thank you for stepping up and chairing this session. And hopefully you can continue to express your interests in this area of discussion, and will be party to future discussions. And so, in closing, Sugas and La Masi to all of the people that I've worked with on the energy and mining file. So I'll turn the chair back to you, Peter. Thank you.
Peter, do you mind if I replied quickly to two things that they've raised?
Yes, please do. I was actually going to ask you if you could.
Okay,
Thank you.
thanks. I think a piece of where you're going, Dave, when I would describe occupying the field, when we rely on our our ancient laws, ancient protocols, and some are doing work to create their own laws, right? In my experience, Dave, we don't have to go that far. In Trans Mountain Expansion Project, we pulled out our Stalo Heritage policy that we did in 2003, and it completely stopped the project, and I'm sure it costed them tens and tens of millions of dollars. But the key there, Dave, is that we had one policy covering 24 Stalo villages. So not only a big geographical footprint, but the 24 chiefs standing behind a single policy. So we didn't worry about legislation or regulation. It was a policy statement on our past. And what I've raised with my chiefs, and I raised that to Union BC Indian chiefs 2 meetings ago, when it comes to mining, why don't we as BC First Nations formally adopt the Initiative for Responsible Mining Assurance as the minimum standard right across the board? So those kinds of activities, Dave, I think will go a long way in changing the game field. But the piece that's missing there is like this, so many of us don't have capacity to engage fully around energy and mining. So we need to find ways to make sure the Energy Mining Council is properly staffed up. So, we can throw a work at them, give me a policy on an environmental management plan regarding mining, around energy production, around carbon sequestration, and you do that work for us and report it back to us, which you've done in the past. And we've got to build the Mining Council into an institution and have more of a direct relation with proponents like BC and Canada. Really appreciating Robert is here. He's always an anchor here in advancing things. And Robert's heard me say this before, with all due respect to the Leadership Council, those are the busiest people in the world. We need to build the competency capacity of the Mining Council to occupy that space fulsomely. And Dave, I compare that to my work with the First Nations Education Steering Committee. I've got 130 board members, over 100 staff, and we have a direct working relationship with the Leadership Council, but they expect us to do all the work and only go to them when we need help because they're so busy, right? So positioning the Energy Mining Council that way across your mandate in an effective and efficient way. And then the last comment here is what you brought to the Mining Council right from the get-go day was just tremendous. So I'm happy to hear to support and participate anywhere I can. And I'm really confident you might be coming to a relief where you could share freely as you will as a citizen living in my backyard. And I do owe you some fish, Dave. I'll stop by in the next few weeks. But the ability to transition and retain some of your tremendous experience and knowledge here would be great. And I look forward to further conversations with you and continuing to learn from you as well. Thanks for everything you've done over the years, Dave.
Thank you, Tyrone.
Yeah, thank you both. It's just an incredible opportunity for all of us to even hear the conversation. So, kind of cheers to you both. And Tyrone, could you kindly let us know when the fish deliveries will be happening?
Put it this way, I'm taking a month off last week of July, first 3 weeks of August. I'll be fishing that whole time.
Yeah, okay. Byron, do you have a couple quick words before we go? Well, I guess not. Maybe that's a hand that he put up a while ago. So, goodness sheesh, everybody. Thank you very much.
Yeah, I do have a comment. Yeah, I didn't
Go ahead.
realize I was muted. Just a quick comment. I'd like to thank people who presented, but also in particular, I think we should all take this moment to thank Dave for his work. And this goes back, he's been a minister, he's been elected, he's been First Nations, been for his own nation, and also for First Nations of British Columbia and the Yukon. Dave has done some incredible work over the years, and we're all better for that work. And Dave, I think we can all say that we really do appreciate everything he ever done. So I think now that you can actually take the time and become a wise old elder and swing it like a bat. And I hope to hear you around, adding and still participating in a lot of these functions. Okay, thanks, Dave.
Yeah, thanks. Yeah, Dave. Dave has been around for a while, and I remember last century working with Dave and in the north here, where both our homelands are, and it's been an amazing and learning experience for me, and I think for many people who interact with Dave. Every time you get to hear him speak or see him, meet him, you can feel the energy and feel everything that he's done. It's been amazing. So many trend-setting things that he's done, and firsts all through his career. It's been amazing in the Yukon and in British Columbia as well. So it is a sad day, Dave, or will be when you do retire. But at the same time, it's we all recognize the work that you've done over the years. So again, goodness cheese, masicho. So thank you, everybody, for the day. Thank you for making time in your day. It's a very informative day. I want to thank all of the presenters and the speakers for sharing with us at this early stage of engagement of CC Couscous. I also want to thank all the attendees and say thanks for all of the questions and insights you brought to the table. And if there's any more, please just send them along to probably Mark at First Nations Energy Mining Council. We're all going to continue this important work that affects our rights and title, the environment, the economy, and so much more, our social being, our existence on this planet. So let's keep going, keep working, and looking for partnerships. So with that, let me say thank you. And one more time, have a great afternoon. Goodness sheesh. Bye.